for 10 minutes. Already we got the message. The class will start in 5 minutes now. Can't wait what now? Every day I'm starting the class on time now. Can't wait for 5-10 minutes. Why the class is delay? Why you want all these reasons? Already informed to you now. Teacher is also a human being now. You will have some work is going to be there now. When every day what I am taking the on time and what we are exceeding the time now. Can't wait for what? 5 minutes now. I've already mentioned there what I'm an important caller there now. That's why I'm from the technical team to upload it what the information so that the class will start in 5 minutes now. Can't wait for 5 minutes. And what is the reason why the class is delayed? Whether class will start or not. You're all waiting. That's why exactly 8 o'clock you got a message now. I came to the office, but I was an important call now. But once I start the class up to 12 o'clock, I cannot take a break now. I will not take it now. Should understood what now? Some common sense is required now. If a problem is going to be there every day, if the class is going to be delayed, you can have the question now. When you are starting the class every day and I'm not taking any break in between, and since you are waiting, already I have given a information, you received it. Technical team already I informed them to what now? Class will start 5 minutes. I was an important call that was slightly 5 minutes is delayed. What is the reason why the class is not started? Who is this Guptamsh Kumar now? Abhishek Kumar Pandey, why the class is late? How much late is there now, my dear friend? Mr. Guptamsh Kumar and Abhishek Kumar Pandey. Try to have some patience now. Already about 8 o'clock, you got a message. Dear student, class will start 5 minutes now. If the class is what half an hour or 20 minutes, if it is unable to start it, then you can what ask now. And you already got an instruction. The class will start 5 minutes. I am starting at 8:10. 5 minutes is delayed now. Should have some patience is required now. Or if every day the class is going to be delayed, you can question it now. Only few friends are like this now. Mr. Guptamsh Kumar, Abhishek Kumar Pandey. So yesterday I completed the sign convention for axial load shear force bendiment. Only you have to study the twistement, sign convention you have to study it. And what the bendiment sign convention you have studied now. Whenever the top surface gets contracted, is a positive. When top surface gets contraction, it's going to be a sagging bending. Or concave surface is upwards, is a positive bending. That is called as a sagging bending. When bottom surface gets contracted, it is a hogging bending. It is taken as a negative. That is, when convex surface upward, is going to be a negative bending. Generally, all the textbook they are discussing, because beams are always what now? Horizontal member, mostly beams are subjected to vertical bending. In case of beams, either top surface gets contracted or bottom surfaces gets contracted. In beams, mostly 99% in beams are always horizontal. They are subjected to vertical bending because beams are what loaded with a VTSL. Every VTSL equal to one shear force and one bending in the vertical plane. But machine components are loaded by VTSL as well as HTSL. VTSL as well as HTSL. And because of the HTSL, you are going to get a one shear force and one bending in horizontal plane. One shear force and one bending in horizontal plane. Same thing. So when a horizontal member is going to be there now, either it may bend in vertical plane, it may bend in vertical plane, or it may bend in horizontal plane. So this horizontal member can be bent it in what? In two planes, that is vertical plane as well as horizontal plane. In vertical plane, you can bend it in such a way that either top surface gets contracted or bottom surface gets contracted. Bottom surface gets contracted. Then you are getting the top is going to be convex surface. When top surface gets contracted, you are getting a concave surface. Same thing what now? In horizontal plane, we can bend it such a way that what a bottom surface gets contracted, sorry, backside surface gets contracted or front surface gets contracted. The backside contraction you are taken as a positive. Same thing when a member is vertical. This can be what now? Twisting couple in horizontal plane. So bending couples are in profile plane or vertical plane. Vertical plane. So this member can be bended in what now? Vertical plane. Such that left side may contract or right side may contract. But left side contraction you have taken a positive. Right side contraction is going to be a negative. Next. This is what a profile plane bending now. Front contraction negative, back side contraction is going to be positive. Next, when a member is kept perpendicular board, so this can be bended in a twisting couple in vertical plane, twisting couple in vertical plane. Then bending couple will be either in horizontal plane or profile plane, either in horizontal plane or profile plane. So this can be seen in what now? Side view, that the profile plane. Here top surface gets contracted, it is going to be a what? A positive. Top surface gets contraction, is going to be a positive, that is the sagging. Next, bottom surface gets contracted. Bottom surface is going to be gets contraction. Bottom surface gets contraction is going to be negative. Bottom surface gets contraction is going to be a negative. Next, horizontal plane. But you are going on which side now? Right side. So right surface gets contraction. Right side surface gets contraction. It's going to be a negative. Horizontal plane is coming on what? Which side now? Left side. Left side contraction is going to be a positive. So any member can be bent in two perpendicular planes. Which planes now? The planes which are perpendicular to plane of cross section. The planes which are perpendicular to plane of cross section. So member can be bended in always in the planes which are perpendicular to plane of cross section. When a member is horizontal, cross section in profile plane. So which planes are perpendicular to profile plane? Horizontal plane as well as vertical plane. When a member is vertical, cross section in horizontal plane. So which planes are perpendicular to horizontal plane? Profile plane as well as vertical plane. Profile plane as well as vertical plane. And when member is what now? Perpendicular to the board. When a member is perpendicular board, cross section in what? A vertical plane. So which planes are perpendicular to vertical plane? Horizontal plane and profile plane. So blindly what is the sign convention now? Backside contraction positive, top contraction positive, left side contraction positive. But how to identify which side is contracted? You have to see the direction of the couple. These couples are going on the backside contraction. These couples are going the top side, top contraction. They are going on the vertical plane, left side. Left contraction is going to be positive and vice versa. Estimate or torque and its sign convention. What the definition you have studied now? Any cross section at any cross section is equal to algebraic sum of distinct couples which are either on left hand side or on right hand side of that cross section. Estimate at any cross section is said to be positive. When double arrowheads of twisting couples on either side of the cross section are acting twistment at any cross section is said to be positive when double arrowheads of twisting couples on either side of the cross section are acting towards that cross section and vice versa. We have studied bending couples are represented by arc of circle, twisting couple by semi-closed ellipse. In all Indian author textbook, the twisting couples are represented by semi-closed ellipse. Both are couples only, but why two different representation? Because bending couple is a perpendicular to cross section. It is a normal load. Twisting couple is a parallel to cross section. That's why two different representation is going to be required. Even though both are couple, one is a perpendicular to cross section, one is parallel to cross section. That's why two different representation. But in foreign author textbooks, in place of the semi-closed ellipse, we are using the double arrowhead. Double arrowhead. Generally, a load is represented by single arrowhead. A load is represented by single arrowhead means the force. If a load is represented by double arrowhead means a twisting couple. So once you convert the twisting couple into, most of the textbook they are giving the semi-closed ellipse only. But we are following the double arrowheads only. Now once you convert into double arrowheads, the sign convention same as the axial load. Axial load means they are acting away from the cross section is positive. Toward the cross section is negative. Axial load is negative when it is acting away from the cross section. Toward the cross section negative. Now if you convert into double arrowheads, the sign convention of the twisting moment or torque is simply opposite to axial load sign convention. Axial load sign convention. That only you are going to discuss it now. So everywhere I mean the twisting moments are representing by twisting couples represented by double arrowheads. So that's why what a torque diagrams same as the what now axial loading diagram. Only simply difference is what now axial load is positive when away from the cross section, but here is toward the cross section is positive. Now how to convert into double arrowhead? By using the right hand thumb principle. By using right hand thumb principle. You might have studied this principle already in the theory of machines. Double arrowheads. What the meaning of this now? How to convert the twisting couple into double arrowhead? By using right hand thumb principle. What the meaning of this principle now? So to convert the twisting couple into double arrowhead, you have to use the principle of right hand thumb principle. So what is the meaning of right hand thumb principle? What should be a first step now? First, identify the plane of the twisting couple. Identify the plane of the twisting couple. The twisting couple in which plane? Horizontal plane. When twisting couple in horizontal plane for vertical member. For vertical member, twisting couple in horizontal plane. First, identify the plane of the twisting couple. See a twisting couple in a horizontal plane. Next, take your right hand. Take your right hand. Then, curl the fingers of right hand. Curl the fingers of right hand. 4 fingers and thumb is there. Curl the fingers of right hand in the same plane of the twisting couple and same direction. Assume what this couple is like this now. Twisting couple in what a horizontal plane. So this horizontal plane means you have to see from the top. Then curl the fingers of right hand in horizontal plane in clockwise direction, or this is anti-clockwise direction. Anti-clockwise direction. Then take your right hand, curl your fingers in horizontal plane. So where you can see my curling of my fingers now. These fingers in what now? Curling can be seen in the top view. So there in what top view means horizontal plane. Then see the thumb direction. So thumb is what? Upward. So this thumb direction will give the double arrowhead. Double arrowhead. Fingers will decide the what now? Plane of the twisting couple and direction of the twisting couple. So these fingers are curled in horizontal plane. So where you can see curling of my fingers in horizontal plane. And what the direction of this now? Seeing from the top, it is a anti-clockwise. Then thumb is going upward. Then this twisting couple, which twisting couple? When a twisting couple in a horizontal plane anti-clockwise, then it should be represented by a double arrowhead upward. Double arrowhead upward. So thumb will decide the what now? Thumb will decide the direction of the double arrowhead. Thumb will decide the double for this twisting couple which in a horizontal plane, anti-clockwise direction, then should be represented by a double arrowed upward. But the finger direction will decide the what now? Right hand finger direction decide the couple direction. Fingers direction will decide the plane of the twisting couple and direction. Now these fingers are what? Curled in horizontal plane. And the direction is clockwise, anti-clockwise, sorry, from the top. In finger. Suppose the twisting couple is in horizontal plane clockwise. This is in what now? Seeing from the top is a horizontal plane clockwise. Then what I have to do it now? Take your right hand, curl your fingers of right hand. So where you can see the curling of my finger now? Right hand fingers from the top. Seeing from the top, it is going to be a clockwise. Now the thumb is going downward. So means that the double arrow should be shown in the downward. Downward. So whenever a double arrow is going to be downward. Now this is what toward the cross section or away. Toward this cross section is a positive. But in the previous case, this double arrow is what upward means away from the cross section. It is going to be a negative. Next, when a member is horizontal, twisting couple in which plane? Now, profile plane. Twisting couple is in profile plane. Assume like this now. This is what a member like this now. Twisting couple in which plane now? Member is horizontal. Twisting couple in which plane now? Profile plane. So this is a twisting couple. So I am seeing from the what now? Whenever a profile plane, either you can see from the left side or you can see from the right side. I have already mentioned default. I am assuming whenever the what now? Twisting couple in profile plane, I am seeing from the right side. Whenever a twisting couple in profile plane, I am seeing from the right side. So seeing from the right side, this in which plane? No, profile plane. Seeing from the right side, it is going to be anti-clockwise. This coming away from the board or towards the board? Away from the board. Board is like this now. This is what now? This couple is going towards the board. Means it is what now? If it is going to get it out here now. In that case, what do you have to do it now? Keep your notebook like this now. Keep your board is nothing but your notebook. And you should assume that you should stand either on the right side or left side. You should be in my position. Should assume that You should standing on either on the, if you see from the front, we cannot see it now. This can be seen from the side. So you should assume that you are standing in my position. That is what now? Either on the right hand side or from left hand side. I'm standing on the right hand side. So seeing from the right hand side is the anti-clockwise. This is clockwise. Now first time I asked me what now? This couple is like this, anti-clockwise. Which plane? No, profile. First you have to identify the plane of the twisting couple. The twisting couple in profile plane. And what the direction now? Anti-clockwise from right hand side. Then what do you have to do it now? Take your finger, take your right hand, curl your fingers, curl your fingers. So where you can say curling of my fingers now? Side, that's the profile plane. So what the direction of these fingers now? Seeing from the right side the anti-clockwise. Then see the thumb now. This thumb is going which side now? Right side. It's going on the right side. Means this twisting couple which is in a profile plane anti-clockwise. Then it should be showed by what now? Double arrowhead towards the right side. So whenever a twisting couple is shown by what now? Double arrow towards right side means it is a what now? Twisting couple in profile plane and anti-clockwise direction from the right hand side. Now suppose the couple is like this. Is a profile plane clockwise, seeing from right side. Then what do you have to do it now? Curl your fingers like this now. So now the fingers are what now? These fingers are what now? Seeing from the right side. The fingers are going towards the board. Fingers are what now? Towards the board. So I'm seeing the finger from the right side. It's going to be anti-clockwise. Then thumb is going what? Towards left side. Towards left side means whenever a twisting couple in profile plane, clockwise, then double arrowhead is going to be towards left side. So whenever a double arrowhead is towards left side means it is going to be, the twisting couple is going to be in profile plane and in the clockwise direction from the right hand side. That's all. So if somebody will ask now, how we are deciding the double arrowhead? What the first step now? First you have to identify the plane of the twisting couple, then direction of the twisting couple, then what the next step now? Third step is what now? Curl the fingers of right hand. Curl the fingers of right hand in the same plane of the twisting couple and same direction of the twisting couple. So fingers will decide the what now? The curling of the fingers will decide the plane of the twisting couple and direction of the twisting couple. Then you have to see the thumb now. The right hand thumb will decide the direction of the double arrowhead. Double arrowhead. So always what? The thumb will decide the what? A right hand thumb direction will decide the double arrowhead. But thumb direction decided based upon the finger directions. But finger directions depend upon the couple direction. That's all. This is what now? This couple can be in which plane now? Where you can see this now, side view, that's the profile plane. Seeing from the right side is going to be a clockwise. Seeing from the right side is going to be a clockwise. So what is the direction now? This couple is in a profile plane and seeing from the right side is the clockwise. Seeing from the right side is the clockwise. Then what the double arrowhead now? Couple is in profile plane. Direction is clockwise. Then curl your fingers clockwise, seeing from the right side, that towards the board, and see the thumb. Thumb is towards left side. So this is decide the what now? Right hand thumb direction. right hand thumb direction. Now, how to decide it now? Whether whatever this direction, is it which direction? A profile plane clockwise. Profile plane clockwise from right side. Now, this double arrowhead is what? The correct or incorrect? What you have to do it now? You should understand right side. Then you put your thumb towards right side. This double arrowhead which side now? Towards left side. Then you put your thumb towards left side. Put your thumb towards left side. Put your thumb towards left side. Then see the fingers now. Fingers are what? Towards the board like this now. Whether you want to decide the correct or incorrect, what you have to do it now? Put your thumb towards left side. Then see the fingers now. Fingers are what now? Towards the board. So seeing from the right side is going to be a clockwise. So what is representing now? Twisting couple in mostly we are dealing with the shaft. Shafts are horizontal member. Shafts are horizontal member. When shafts are horizontal, then twisting couple in profile plane. Twisting couple is in profile plane. Then whenever a twisting couple is in what? A profile plane clockwise. Whenever a twisting couple is a profile plane clockwise, blindly what? Keep the double arrow towards left side. You can try to remember it also. Those you are unable to visualize the right hand now, try to remember now. So whenever a clockwise, twisting couple in clockwise direction from right hand side, directly what? Keep the double arrow is going to be towards left side. Profile plane. Seeing from the right side means obviously in which plane? A profile plane. This is what now? This is anti-clockwise direction. This is anti-clockwise direction from the right hand side. Anti-clockwise direction from the right hand side. Then what you have to do it now? Curl your fingers in profile plane anti-clockwise direction. Then thumb is going to be towards right side. So this is a representation of suppose somebody want to mention from left side, then this will become the anti-clockwise and this will become the clockwise. Now shall I take the positive or negative now? This twisting couple. Some of the algebraic, some of the twisting couples I am giving towards right side. Shall I take the positive or negative? Positive torque or negative torque? Out of these two, which is the positive torque and which is the negative torque? Sorry, the positive and the negative. We cannot decide it now. Suppose the axial load is like this. Axial load is like this. Is the tensile load or compressive load now? We cannot decide it now. We should know the cross section. Suppose if the member is like this, then there is a compressive load. So without knowing the cross section, we cannot decide it now. Is the axial or tensile load or compressive load? We don't know. So first of all, you should know the cross section or member. Suppose the member is like this, then the compressive load. Suppose the member is like this, then this is going to be a tensile load. Same thing here also. What now? Is it a positive or negative? We cannot decide it now. Suppose the shaft is like this now. Now it's going away from the cross section negative. Suppose the shaft is like this is going to be a positive toward the cross section. Suppose if I am keeping the shaft like this now it's going away, it is a negative. So here what now? We are deciding only the direction only. But we cannot decide positive or negative cannot be decided. To decide the positive or negative, either you should know the member position or cross section is required now. So which is positive, which is negative, we cannot decide it now. What do you mention now? Arrowheads, they're acting towards the cross section. But where is the cross section, we don't know. When a member is what like this now, it is cross section on which side now? Right side, then this is going away. If the member is like this, then the towards the positive will be there now. Similarly, what this couple, is a positive or negative, we cannot decide it now. This bending couple is what now? Positive or negative, we cannot decide it now. If the member is kept like now, this is going towards the top. Towards the top. But if the member is what now? Like this now. Member is like this. Then this is what coming on which side now? Bottom side is a negative. If the member is here now, this going towards the top. But if the member is what now? This side now. Then this going towards the what? Bottom side is a negative. So we cannot decide about is it is positive or negative now. So we should know the member position is required now or cross section is required. Now this is what now? In which plane? A horizontal plane. So when the twisting couple in horizontal plane, vertical member. For vertical member, this is what now? Profile plane. Means when the twisting couple in profile plane, these are going to come across when member is going to be horizontal. These are valid when the member is horizontal. This is valid when member is vertical. When member is vertical, twisting couple in horizontal plane. Now this is a clockwise, anti-clockwise now. This direction is the clockwise, anti-clockwise. It is a anti-clockwise. So this twisting couple in which plane now? Horizontal plane, anti-clockwise. Then how to decide it now? So curl your fingers in a horizontal plane, anti-clockwise. Then thumb will go upward. So what the double arrowhead here now? Once again, the positive or negative, we don't know. We should know the member position. So what is representing now? Twisting couple in this twisting couple in which plane? Horizontal plane. Means this is valid when member is going to be vertical. Sir, the top or what up? Sir, you previously written right side. The top or what now? Bottom. Default horizontal plane means you have to see from top only. We are having how many views now? Front view, top view, left side view, right side view. So whenever a horizontal plane means default you are seeing from top. Whenever a horizontal plane means default you are seeing from the top. We don't have the bottom view concept and we don't have the back side view concept. Horizontal plane means default you have to see from the top only. But profile plane means either you can see what the left or right. That's why always you have to clearly mention from which side now, because you're having a left side view and right side view. What the other way can represent it like this now? It is also going to be clockwise. It is also clockwise. What the other way can this can also represent it now? You can see this is what now? This is a clockwise. Both are clockwise only. Both are clockwise only. Same thing. Either you can show like this or you can show like this. Same thing, this also can be what the other way can show it now. Because some students are getting a confusion now. So what the other way can show this now? And once again, what this other way can show it now? Now this is in which plane now? Horizontal plane. Seeing from the top, it is going to be a clockwise. This is what a clockwise. So then what you have to do it now? Curl your fingers in horizontal plane clockwise. Then thumb is going downward. So here double arrow is going to be what is it representing now? Clockwise direction. Once again, positive or negative depend upon the member position. If the member is kept like this, it is going to be a negative. If the member is kept like this, it is going to be a positive. Now what is the sign convention now? So some of the twisting couples, double arrowed I am getting like this now towards the cross section is a positive. Then automatically on the other side what you are going to get now? On either side you will get the same value, opposite direction. So now this is going to be about a positive torque. Both the double arrows are towards. Plus T. Now somebody want to decide this is a clockwise, anti-clockwise. How to decide it now? Put your thumb towards left side. Put your thumb towards left side. Put your right hand thumb towards left side. Then fingers are towards the board. Mean couple goes towards the board. So seeing from the right side, it is going to be a clockwise direction. Seeing from the right side is a clockwise direction. Always in the question you are going to give this now. Now you have to convert it now. And this is what how to decide it now. Double arrow is going to be towards right side. Double arrow is going to be towards right side. Then fingers are coming away from the board. Then couple is coming away from the board. Seeing from the right side is the anti-clockwise. And if they are away, it is going to be a negative. If we convert like this, the problems are same as the axial loading problem. Only equation will change. Axial says what a P by A. Torsional shear says what a T by ZP. Only what now? Once you convert into double arrowhead, your torque diagram principle is same as the ALD. Only the difference equation will change. And the sign convention also easily remember, simply opposite to axial load sign convention. So both are going away from the cross section. What the sign convention written now? Double arrows of twisting couple on either side of the cross section are acting toward the cross section now, and vice versa. These are towards. Is a positive. It is away. In all the textbook they will give this only. But I am giving all the possibilities. Then this is valid about when the member is horizontal, shafts are horizontal. But sometimes the members are vertical. When members are vertical, this is required now. When member is vertical, twisting couple in which plane now? Horizontal plane. But most of the times shafts are horizontal. So whenever a shafts are horizontal, twisting couple in profile plane, then you can also remember directly. So for horizontal member, twisting couple in clockwise direction from right side means double arrowed is going to be towards left side. Twisting couple in anti-clockwise direction from the right side means double arrowed is going to be towards the right side. It is towards right side. This you can remember it now. What type of float it is now? Vertical ETSL. Vertical ETSL downward, vertical ETSL upward. What you have studied now? Twisting couples are always formed due to two equal parallel opposite ETSLs. This is called as what now? Vertical ETSL downward. Two equal parallel opposite forces. Two equal parallel opposite forces will form a couple. But these are what now? ETSL. So these two will form a couple in which plane now? This curve is what now? Back side. This is the front side. This curve is the back side one. This is the front side now. So what the no? Back side is the downward. Front side is the upward. So these two can be seen from where now? Side view now. So this is a downward. Is the front upward. This can be seen. Both the markers can be seen in the side view. Already have studied now. So what this direction now? Clockwise. What the couple direction? What the distance between the D? So what the twisting couple? Clockwise. Seeing from the right side. Then what should be the direction of the double arrowhead? Towards left. What should be the direction of the double arrowhead? Towards left. And what about these two now? This is parallel to which axis now? VCA. This is parallel to which axis now? HCA. So this is horizontal ETSL. Horizontal ETSLs. These are horizontal ETSL. Now top one is about the outward or inward now. This is coming what now? Away. This is what now? Away. Means outward. This is going towards the board. This is towards the board. Towards the board. Suppose the this is what now? Polar axis. Instead of showing, I am showing this is the centroid. This is the centroid of the cross section. So this is what a polar axis, VCA and HCA. But this is representing towards right side. This is all you have studied when you have studied the twisting couple. This is towards right side. This is front side. That is coming away from the board. This you are calling out towards right side, towards left side, upward, downward, front side. Front side means away. This is what a negative z axis is what a towards back side. Negative z axis is what now? This is what a right side, negative x axis left side, upward, downward. This is what now? Front side, and this will be back side, negative z axis. So this coming on which side now? Positive z axis. Positive z axis means front side. And this is negative z axis. Negative z axis means back side. Like this now. So once again these two can be seen in where now? Is coming away from the board. These are towards now. Once again these two can be seen in profile plane. So once again the twisting couple. But what the direction seeing from the right side? Anti-clockwise. It is the anti-clockwise. This is going to be clockwise. This is the anti-clockwise. What the couple now? Phi P into D. What the distance now? D. And what about this? This is going towards. This is going towards. This is coming away. Here towards means what now? Towards the board means back side. Towards the board means back side. And away from the board means front side. So top one is what now? Top one is towards the board. Bottom one is away from the board. That is towards the board means back side. This is what now? Away from the board means front side. So what is this direction now? Clockwise. So this is a clockwise, this is anti-clockwise, and this is a clockwise. Now how to show it now? But generally in the problem they will not give all this thing now. Always twisting couple is formed due to what? Two equal parallel opposite ETSLs. But in the problem they are showing like this. Mostly in the problem they are going to give the front view. Front we are able to see rectangle. The front view. But this total line now, this line is represented, this total cross section represented by vertical line. This total cross section represented by this vertical line. So all these vertical lines are the what now? This total cross section is represented by vertical line. So all these vertical lines are the cross sections. Now this is the centroid A. The longit axis. The front view. Now this is a clockwise, anti-clockwise. Now clockwise from right side. Then what should be the direction now? This is what? 2PD. 2PD. 2T I'm calling now. It's the 2PD. Means T means how much is now? T I'm assuming as P into D. The clock. Now this is going to be anti-clockwise. 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 How much is now? 5PD. 5T. Now this is going to be 3PD clockwise. They're all CX or CY or CZ. They're all in which plane? No, profile plane. For profile plane, which axis perpendicular X. Therefore, they're all nothing but the CX. CX means you have to take the moment of inertia X. X axis means what? A polar axis. You have to take the polar moment of inertia. Now directly this becomes the twisting moment because the extreme end. So what the twisting moment at torque at C? 2PD. But the twisting moment now? 3PD. But the twisting couple. Here you are going to get the two twisting moment. It is not a twisting moment now. This is a twisting couple. These are all twisting couples only. But this twisting couple will become the directly twisting moment. And directly this will become the twisting moment. But this will become only a twisting couple. Here you are going to get the two twisting moment. If you ask the most of students what the maximum twistment means, they are going for 5PD. 5T they are going to give it now. In all the questions they are giving directly like this now. But directly couple cannot be applied now. Couple is applied or force are applied now. Force are applied. Some question they are going to show like this now. Foreign author textbook. But most of the Indian author question they are going to show like this now. Couple cannot be applied. Always forces can be applied now. So whenever we want to get a twisting couple, we need about a two equal parallel opposite ETSLs are required. But if you ask the maximum twisting moment, everybody is going to give directly 5T, the incorrect now. This is a twisting moment, this is a twisting moment, but this is twisting couple. Now, here how many loads are 0 now? Axial load 0. Shear force 0, bend moment 0. When you are going to get an axial load here now, if you want to get an axial load experiment, one axial load is required. There is no axial load. And to get a shear force, we need a constant point load. There is no constant point load. Shear force 0. And to get a bend moment, bending couple is required. So there is no bending couple means bend moment is 0. No constant point load means no shear force. No axial load means axial load 0. So only you are going to get a twisting moment only. Every cross section, how many loads you have studied? 4. But here you are getting only one twisting moment. Same thing here, one twisting, but here you are going to get the two twisting moments are going to be there. But how to decide the positive or negative now? How to decide the positive or negative? Convert into double arrowheads. Now I can check it the equilibrium or not now. Clockwise, how much I am getting now? 3t and 2t, 5t. This is the anti-clockwise equilibrium. Some of the force are 0, some of the couples are 0. So it is the equilibrium now. And generally this is represented by longitude axis. What is this line now? Longitudinal axis. What is the direction now? Clockwise. So what the direction now? What the double arrowed is? Clockwise. Clockwise. So fingers should be towards the board and thumb is going to be towards left side. So double arrowed is going to be towards left side. So you directly can remember it now. Whenever a clockwise means put the double arrow towards left side. T. After keeping, how to cross check with the correct or incorrect now? How to decide the clockwise correct or incorrect now? Put your thumb towards left side now. Put your thumb towards left side. Then fingers are towards the board. Fingers are towards the board means couple is towards the board. Then it's going to be a clockwise. Now this is anti-clockwise. Clockwise you have kept it towards left side. Automatically anti-clockwise is going to be towards right side. Towards right side. And this is once again clockwise. Clockwise means so directly what the twistement at C 2t towards either positive or negative? Positive. But what about the twistement here now? Negative. It is going away. It is going away. Away from A or towards A. Away is a negative. So what the twistement at C? Plus 2t. What the twistement at A? Going away. Minus. So if we ask at C, how many loads are 0 now? Axial load 0, shear force 0, bendment is 0. But what the twistement or torque? Plus 2t. Plus 2t. Next, at A, axial load 0, shear force 0, bendment is 0, and twistement is going to be minus 3t. Minus 3t. But if you want to get at B, what I have to do it now? B is a junction. B belongs to BC and B belongs to AC. If you ask at C, directly can give it now. And A also can give it now. But this is a positive, this is a negative, going away. But if you ask at B, then what you have to do it now? What you have studied now? 2 times you have to calculate. First, assume the B belongs to BC, one value. B belongs to AB. Then you have to take the take a section. Now this you have taken between B and C. You have taken between B and C. Now how to get the twisting? Algebraic sum of the twisting couples, either on the right side or on the left side. Right hand side, how many twisting couple? Only one. So towards means a positive. So if you want to get at B, what do you have to do it now? Want to find out the twisting at B. First, I'm assuming the B belongs to BC. Then take a section. What the twistment definition? Algebraic sum of the twisting couple either on the right side or left side. But to take the right side or left side, right side only one twisting couple. But left side, how many twisting couples are there? Two. But this going towards is going to be a positive. This by considering on which side now? Right hand side. But if it is axial load means it's a negative. If a single arrow hit the axial load, then it is going to be a negative. Suppose somebody has taken the left side, still you should get the same value. If you take the left side, how many twisting couples are there? No, two. If the towards are away, towards is a negative. Towards is a positive, and this is negative. Suppose somebody has taken the left side, it is the towards, and this 3t is going away. Still you are going to get the 2t. That only mention whether you take left side or right side, you should get the same value. So when B belongs to BC, what the twistment now? 2t means C to B twistment is same. C to B twistment is same is a constant. It is not a function of x now. It is not a function of x. This is a distant x. Means the constant. Means C to B is what? A twistment is constant. Then you are going to get the Tag diagram is going to be a rectangle. You are going to get it. Similarly, same thing. To get a twistment B belongs to AB member. Here better to consider which side, na left side or right side is better, na left side. Left side only one twisting couple is there, only one twisting couple, but this going away. Away means negative. This is by taking on the left hand side. Left hand side. But if you take the right side, how many twisting couples are there? No, two. This going away from x1. Away means negative. Minus 5t. But this is towards. So finally, what that twistment B? B belongs to BC, B belongs to AB. When B belongs to BC, what the value? No, 2t. When B belongs to AB, how much? No, minus 3t. So what the twistment B? Larger value. Which is the larger value now? Minus 3t. Now this is what now? Is a twistment or twisting couple. How it is distributed now? How this twisting couple is distributed? When B belongs to BC, is acting as a twistment of how much now? Plus 2t. When B belongs to AB, is acting as about a minus 3t. So here there are two twistments are there. But here you are going to get only one. You can see now. When C belongs to, at C, what the value now? 2t. C to be the constant. So finally, what the maximum twistment in this entire member? What the twistment at C? Minus 2t. What the twistment at A? Minus 3t. And what the twistment at B? Minus 3t. So what the maximum twistment now? Minus 3t. Larger of twist minute C, larger of twist minute B, twist minute A. What the larger value now? Minus 3t. But most of students, they are going to give the 5t. Most of the students are going to give the 5t. 5t is not a twist minute, it's a twisting couple. If you ask to find out the maximum torsional shear stress, what the maximum torsional shear stress? Now 16t by pi d cube. So which twist minute I have to take it? Now minus 3t. But most of the students are going to take the 5t. What the maximum torsional shear stress here at now? T by ZP, that's 16t by pi d cube. Then T means everybody is going to take the 5t, they are going to take it. 5t, they are going to take it. But what the maximum twist minute? Now minus 3t. The same thing you studied yesterday now. Only what this extra thing now. We are converting to double arrowed. But most of the problem they are showing like this. But couple cannot be applied. Bending couple is formed due to, if I want to get only bending couple, that is what now? If you want to get only bending couple at a cross section, that is possible because of what now? Two equal parallel opposite eccentric axial load. But if you apply eccentric axial load, what do you get now? One axial load and one bending couple. So whenever you want to get a only bending couple at any cross section, then you have to apply the two equal parallel opposite eccentric axial loads. Similarly, if you want to get a only twisting couple, then you have to apply the what now? Two equal parallel opposite ETSL. But if I am going to remove this now, if I am going to remove this only one ETSL, then in that case what is it now? Every ETSL equal to one TSL plus one twisting couple will be there. So remember what now? Whenever you want to get only twisting couple at a cross section, that is possible only what now? Two equal parallel opposite ETSL. But if I am going to remove this now, only one ETSL. Yesterday what here every ETSL equal to one TSL plus one twisting couple, and due to TSL you are going to get a shear force and bendment. If I am going to remove this now, only this one will be there. Then you are going to get a shear force, bendment and twistment, three are possible now. If I am going to remove this now, only one ETSL is applied. If only one ETSL is applied, on that member you are going to get a shear force, bendment and twistment. But if you want to get a only twisting couple at a cross section, that is possible only when two equal parallel opposite ETSL. Similarly, if you want to get only bending couple, then you have to apply the two equal parallel opposite eccentric axial loads. But if you apply only one eccentric axial load, what happens now? One axial load and one bending couple will be there. So whenever you want to get only bending couple, what the option now? At any cross section you want to get only bending couple, you have to apply the what now? Two equal parallel opposite eccentric axial loads. But if you apply only one eccentric axial load, one axial load and one bending couple will be there. Similarly, if you want to get only twisting couple, then you have to apply the two equal parallel opposite ETSL. But if you apply only one ETSL, then you are going to get a one TSL plus one twisting couple. And due to TSL, you are going to get a shear force and bendment. This is what now? What the direction, my dear friend? It is going away towards now. It is going away. Away means what? A negative. It is going away from the cross section. Otherwise, you can check it that this is going away. Away is what? A negative. Then what the problem we are getting? But this is towards the positive. But this is away, is a negative. What the doubt you are getting, Mr. Ankush? At A is going away from the cross section, my dear friend, not toward the cross section. We can also check it now. Some of these twisting couples are 0. Towards left side 3t. 2t, 5t. This is towards right side. So sum of this twisting couple is 0. It is also clockwise. It is also clockwise. Clockwise means what now? Double arrow is going to be towards left side. It is also towards left. It is also towards left. But this is acting towards C. It is acting towards C. It is what now? Going away from A. Otherwise, take a section. If you take a section now, this going away is a negative. Take a section towards now. If you want to get the twist minute C, what I have to take it now? This one. If I want to get the twist minute C, B to C the constant, means C is also plus 2t, B is also 2t. And want to get the twist minute AB, take a section between A and B. What you are getting now? Minus 3t. Means at A is also minus 3t and B is also going to be minus 3t. Mr. Manas, I've already explained, still you are repeating the same thing now. How it is plus 3t, my dear friend, it is going away. Check the sign convention now. I've already explained and you are asking the same thing now. I've already proved it also here now. Take a section, it is going away. Away means negative or positive. This is coming towards, is a positive. This is going away, is a negative. Refer your yesterday's lecture. Don't ask Mr. Ayush Kumar now. Yesterday I already repeated and you are asking, sir, why you are getting 2 values, means what should I explain now? Yesterday I slept or what? सो गया था क्या class में? So much of yesterday explained everything. I will not explain once again now. So many times and B the junction, B belongs to BC and B belongs to AB. 2 values are going to be there. I've already proved it also. And yesterday also already you studied. And you're asking, sir, why you are getting 2 values, sir? Probably yesterday you're not attending the class now. Or otherwise, you have slept it. सो गया था सुबह सुबह सो गया था class में आपने. Otherwise, sleeping over, you are sitting in front of the system and your what now? Your world is what now? Mind roaming was there, now world roaming is there, now your mind now. Whenever a load is applied at a junction, whether you apply a constant point load, whether you apply a twisting couple or a bending couple or axial load, we cannot decide the magnitude and direction. That's why you have to calculate the 2 times. Whenever the loads are applied at a junction, axial load magnitude direction cannot be decided. When a constant point load is applied, what? We cannot decide the magnitude and direction of shear force. And if you apply a bending couple, we cannot decide the magnitude and direction of bending moment. And if a twisting couple is applied, we cannot decide the direction and magnitude of the twisting moment. But extreme end we can decide it now because these are the non-junctions. But a junction, Whenever the loads are applied at a junction, whenever the loads are applied at a junction, we cannot decide the axial load, shear force, bending moment, twistment, magnitude and direction. That's why you have to calculate the two times, then only you can decide it now. Both are clockwise only, my dear friend. एक बार देख लीजिए आप बोर्ड में. It also clockwise, it also clockwise, it also towards. It is also what? Towards left side. It is also towards left side. This is also clockwise, it is also clockwise. Therefore, it is also towards left side, it is also towards left side. But this is acting toward the cross section, this is acting away from the cross section. Always you are studying about the statics only. Statics, always your equilibrium. Member should be always equilibrium. Strength thermometer is always a statics. Always some of the forces and some of the couples should be zero. If it is not in equilibrium, then member is going to be displaced now. We are all dealing with the equilibrium condition only. Sir, if it is not in equilibrium, means what is not, that is not possible. Then it is going to be in dynamic condition will be there now. Don't ask all the unnecessary doubts and everything I explained now. Clearly mentioned starting itself now. Strength thermometer deal with always a statics. Some of the force and some of the couple should be zero. In our subject, there is no possibility of unequilibrium condition will not get it now. Always equilibrium condition only will get it now. Those you are getting why the negative, I have already taken a section also. This section valid for AB. Means this will give the twisted A and B. I am getting about minus 3t. Is a constant. What the meaning of this now? Is it depend upon x or independent of x? Independent of x. The value I am getting what a function of x or independent of x. Independent means a constant. Constant. What the meaning of this now? A to be the constant. What the value I am getting? The minus 3t. A is also minus 3t, B is also minus 3t. That is when B belongs to AB. A to B is going to be minus 3t will be there now. Don't leave the basics and ask all these questions now. Check it now. Is a tensile load or compressive load? Tensile. Is a but both are in the same direction or not? Is a positive, is a negative. What the axial load here? Na plus 3, plus 30. What the axial load here? Na minus 10. But both are in the same direction. Everybody is asking, sir, when both are towards left side, one is a positive, why is the one is a positive, one is a negative? They are asking them. This is acting toward the cross section. This is going away from the cross section. So here what now? This is what now? What the axial load at C? Minus 10. What the axial load at A? Plus 30. Both are in the same direction or different direction now? Don't leave the basics and ask unnecessary doubts now. But both are what towards left side only there now. Both are same direction, but this is becoming the tensile load is going away from the cross section, and this is toward the cross section is a negative. And what about this now? What the axial load at B? We cannot directly tell it now. It's a junction. Here there are two axial loads are going to be there now. Two axial loads are there. So how to get an axial load at B? Yesterday already I studied. Don't come to the classes without referring the class notes. So if you want to get at B, what do you have to do it now? Everybody is going to tell what the maximum axial load means 40. It's not the maximum axial load. Here we don't know axial load magnitude and direction. This will become an axial load. This will become an axial load. This will not become an axial load at this cross section. We have studied yesterday about two axial loads are going to be there now. I am assuming B belongs to AB. If I take a left side, it's going away. Here I'm taking the right side. Now what the B? B is coming in AB and BC. So when B belongs to AB, what the value? Now plus 30. When B belongs to BC is what? A minus 10. So what the axial load at B? Larger of this value. What the larger value? Not 30. Larger of this now. Same thing yesterday already studied, and you are asking once again the same question they are asking now. The same thing now. That all I mentioned now. Once you convert to double arrowed, the problems are the same as the axial load. Only difference here what now? Here away is positive, but here towards is positive. That's all. That's the only difference now. Mr. Manas, please try to vote now. Don't ask the unnecessary doubts now. Everything I explained properly now. Sir, why double arrow is going away from A? Both are clockwise or not now? It is kept towards which side now? Clockwise means you have kept it towards left side. It is also towards left side. Both are in which direction is there now? It is also clockwise, clockwise. Clockwise means what? It is going to be towards left side. Is it what? Towards left side. It is also towards left side. Sir, why is going towards left? What should I explain now? Is also clockwise, clockwise. Both are clockwise. Here clockwise means what you have studied now. Double arrow is going to be towards left side. Just now I explained with the right hand thumb principle now. So it is towards left. It is also towards left side. Now, suppose in the question exam, if you ask directly axial loaded B, if you ask axial loaded B, in the question asks what now? Find out the axial stress at A. Axial stress equal to P by A. Axial stress P by A. Everybody is going to take it what now? 40. If you ask what the axial stress at B, everybody write down what? A P by A. P they are going to take a 40. It is the incorrect now. Then how to get the axial load at B? This method. This is the actual method now. First you assume the B belongs to AB member, then B belongs to BC member. 2 times you have to calculate. 2 sections you have to take it. When B belongs to AB, one value. When B belongs to BC, then larger value you have to take it. Generally, most of them are going to make a mistake at the junction only. If you ask the question what now? Find out axial stress at cross section A for B. Axial stress. Most of students what they are going to take it now? What the axial stress equation now? P by A. Then directly they'll take what? A 40 they will take it now. Suppose this area is what now? Its area is 200 mm square, prismatic. But this is a blunder. This is a blunder. So what should I take it now? What the axial load at B? 30. I have to put it 30. If I am going to put the 30, I am going to get 150 megapascal will be the answer now. But one option is given 200, one option is given 150. Most of students they are going to take the 200 now. Yesterday onwards I am repeating now. Whenever the loads are applied at a junction, we cannot decide the magnitude and we cannot decide the direction. If an axial load is applied at a junction, 2 axial load will be there. But we don't know what the magnitude and direction. Therefore, this is the actual method now. Same thing when a twisting coupler is applied at a junction. 2 twistaments will be there. We cannot know, we don't know the maximum, what the magnitude and direction. Same thing we ask what the torsional shear stress, 16T by pi d cube. Everybody is going to put the what? Directly 5T. Everybody is going to put the 5T. And similarly, if a bending coupler is applied, there are 2 bendments will be there. And whenever a constant point load applied, what? 2 shear force are going to be there now. Now, so what how to get an axial load at B? 30. This is the actual method. What this method now? This method is the actual method. What the actual method mean what now? First you have to assume the B belongs to either AB or B belongs to BC. First I assume the B belongs to AB. Then you take a one section. Next assume the B belongs to BC. One section. Calculate it. Finally which are the larger that you have to take it now. Now I'm going to give a shortcut method now. Instead of doing this 2 times now, almost same thing, and this is the actual method now. Now, if you want to directly calculate it now without taking a sections, want to directly find out the axial load at B without taking a section. Previous method, the actual method. But in objective examination, if you want to save the time, you can see it now. Once again, don't ask all this now. Please listen whenever I'm explaining first time. Please listen it properly. When I'm explaining, they are going to focus on other activities. Then they are going to get the doubts now. So how to directly find out now? Now you can listen now. First, neglect this load. Whenever you ask the axial load, shear force, bending and twistment. Whenever you ask the axial load, shear force, bending and twistment. Whenever you ask about the axial load, shear force, bending and twistment at the junction. That is, whenever if an axial load is applied at junction, 2 axial loads are there. Then how to get the 2 values directly now without taking a section. Now this same concept you are using the what now? When you are calculating the twistment at junction, shear force at the junction, bending at the junction. If they clear the same thing, you are going to do it now. So what the first step you do it now? First neglect this value. Whenever you want to get an axial load at junction, first neglect that axial load. Neglected means I'm closing means what? A neglected. If you neglect it, then I calculate the axial load one time. Either you take the left side or right side. Neglect it. If I'm taking the left side, means I'm assuming the B belongs to AB. First neglect it. Now I'm taking the left side, means I'm assuming the B belongs to AB. How do you know it's AB now? I'm taking on the left hand side. Neglect it. Suppose somebody is going to neglecting, they will consider right side, means assuming the B belongs to BC member. So neglect it, I'm taking on the left hand side. What the axial load now? Algebraic sum of the axial load either on the left side or right side. So first you neglect this value. Then calculate the axial load one time. I'm taking the left hand side, means I'm assuming the B belongs to AB. If you neglect it, left hand side, how many axial load is? 1 is there now. This 30 is what? Going away from B or towards B. This B 30 is what? This 30 kilonewton going away from B or towards B. Away. Away means what? A positive. So this is what? By neglecting, axial load at B. Neglect it. Now this here taken positive ion as a tensile load is going away from B. Mean what the sign convention here used it now? This here taken positive, but what is direction? Towards left side. So in this case, what the sign convention here used it now? Towards left side is positive. Why are taken towards left side? Because what is going away from B, tensile load. Then what the next step now? Next, assume the B belongs to BC. Then how to get it now? Previous value, that is axial load AB plus or minus. First you are neglected. Now you consider it now. Consider this value now. Next, by plus or minus applied axial load at B. What the previous value got it now? 30. Then what the axial load at B, or what the applied axial load 40. 40. But shall I take a plus or minus now? When you are calculating here, now which one you are taken positive? Towards left side you are taken positive. But this axial load is what? Towards right side. Since you are taken towards left side is positive, but this load is towards right. By chance is towards left side, then you are taken positive. But this is which side? No, towards right side, minus. So what the value now? Minus 10. So you have to calculate 2 times. Finally, whichever the last. This is nothing but the same as the what now? Section method only. First you neglect this value, calculate 1 time. Then you consider this value, calculate 1 more time. Finally, whichever the larger. So finally, what the axial load at B? First neglect it. Neglect it. If you're taking the left side, means I'm assuming the B belongs to AB. Somebody's take the right side. If somebody's take the right side means it's considering the B belongs to BC. Somebody can also do like this now. I'm neglecting. I'm taking the right hand side. If you neglect it, right hand side, one load is there. But this load is towards B or away from B. Towards B is a negative. Means since I'm considering the right side means I'm assuming the B belongs to BC. If you neglect it, I'm taking the right side. This is what towards B. Towards B is a negative. Now what the sign convention I taken now? Towards left side is what? Not negative. Towards left side is this here taken negative. Next. How to get the axial load in AB? Previous value. Axial load in BC plus or minus at B. Applied axial load at B. For the previous value, no, minus 10. And what this value now? 40. 40. But shall I take a plus or minus now? When you are calculating here, now what the sign convention here is used now? Towards left side you are taken negative. But this is which side? Not towards right side. This here taken negative. Then but this is opposite towards right side. Then you have to take it a plus. So it is what a 30. Here what I was him now? I taken the left side. First means assume the B belongs to AB. Here what I done it? I taken the right side means I'm assuming the B belongs to BC. But when I'm taking the right side, this 10 is what? Towards B. Towards B means a compressive load. But if you take the left side, this 30 is what? Going away from A, positive. So this direction is positive. Towards left side is a positive. But this is towards B is a negative. Put it. The same thing, I'm going to use it now. Similarly, when a constant point load is applied, what I do it? Now, 2 shear force. First, neglect that constant point load. Then calculate the shear force 1 time. Then consider that constant point load. Then you calculate the second time. Finally, which are the larger. If this is clear, the same thing you are going to use it now. We are calculating axial load. First, you have neglected the applied axial load at B. First you are neglected. This is by neglecting. Then it is considering. Same thing when a constant point load is applied. First you have to neglect the constant point load. Then calculate the shear force 1 time by taking the left side or right side. Then you calculate, consider that constant point load, you calculate one more time. Finally, which are the larger? Now same question now. Now I want to get the estimated B directly now. If you ask at B, you have to calculate 2 times. That is just now you studied that is the actual method. Now without taking a sections, directly what you have to do it now? Same principle. I'm neglecting. First you neglect it. Neglect this twisting couplet B. I'm taking the right side. Means I'm assuming the B belongs to BC member. If you neglect it, now this 2T is going acting towards B or away from B? Towards B means a positive. So if you neglect it, what the value now? Either towards minus 2T. Directly what a without. This is for calculation I showed it now, but without calculation also directly can tell it now. Neglect it. Consider this now. This is towards B or away from B? Towards B means a positive. Means when B belongs to BC, the plus 2T. Now this you are taken positive now. Next you consider this value. Both are in opposite direction or same direction? Opposite. This you are taken positive means this is a negative. So by neglecting, how much you are getting? A minus 2T. Then you consider this one, what happens? Minus 2T plus 5T plus 3T. Sorry, this is a plus 2T, is a minus 5T. Minus 3T will be there. Same principle. This is only for your calculation. Without calculation also you can directly tell it now. Neglect it. I'm taking the right side. Now this is what the towards B, positive. So when B belongs to BC, what the value? No, 2T. Then you remove this. Means you have to consider. By neglecting, I got the plus 2T. Now you consider this value now. Both are in opposite direction. This is already taken positive means this is a negative. Plus 2T minus 5T minus 3T. So by neglecting plus 2T, by considering what? A minus 3T. So which is the larger value? Minus 3T. So when B belongs to BC plus 5 plus 2T, when B belongs to AB, it is going to be what? A minus 3T. That's all. You want to show your calculation, you can show it now. If you show this calculation, unnecessary waste of time now, directly can give it now. Neglected plus 2T. Considered 2T minus 5T minus 3T. So by neglecting minus 2 plus 2T, by considering minus 3T. Larger value is what now? Minus 3T. But neglecting at B. But this you are taken a positive. Why you are taken positive now? Towards B. So what the sign convention you have followed now? So towards left side you are taken positive. Next, what the twistement in AB? Twistement in BC plus or minus twisting couple at B. What the previous value? No, 2T. What the twisting couple now? 5T. Now shall I take a plus or minus now? Plus or minus now? Towards left side you are taken positive, but this is towards right side. Since you are taken towards left side positive, towards right side is negative. That's all. So finally, which is the larger value now? 5T or 3T. Which is the larger value now? Minus 3T. Same thing. If a constant point load is there, first neglect that constant point load. Calculate the shear force one time. Then consider that constant point load, calculate one time. Finally, whichever the larger, that you have to take it. Once I'm mentioning when I'm going for the axial load, shear force, bendment and twistment, they will not be explained once again. When you're going for the torsion chapters or why the double arrow taken, you're taken left side or right side, I will not explain because everything is explained now. But this diagram, still some students are going to show like this. Somebody will show like this now. Both are correct only. Now this 3T is going towards left side, it is also going towards left side. Towards right side is also towards right side. And it's towards left side is also towards left side. Now check it now, both all are equilibrium now. But here one students are going to make a mistake is what now? Sorry, the towards A. Now you see it here now. It's going away from the member. This is going away. It is going away from this member. This is also going away from the member is a negative. This is towards the member, towards the member, towards the member. But here only what now? Sir is towards A. Don't see like that now. This going at extreme ends. What do you have to do it now? At extreme ends, check it what is going away or towards the member. It is going away from this member. It is also going away. It is also going away. It is towards the member, towards the member. So towards the member means a positive. It is going away from the member means a negative. Or if any doubt, take a section. Take a section. Now it is going away, negative. Here also going away. So that's why it is what a minus 3t. Both are correct only. Here also what to take a section. Both are going to be what? Both are going to be negative. Either you can represent like this or you can represent like this now. So the extreme ends, don't see the cross section. At extreme ends, see the what now? It is going away from the member or towards the member. At extreme ends, don't see. Some students are going to keep it like this. Sir, is it towards A, sir? Is a positive. Don't see like that now. At extreme ends, see it what now? It is going away from the member or towards the member. It is going away from the member, negative. It is towards the member, positive. Or if any doubt, take a section. Take a section. It is going away, negative. Away, negative. Basics are required. Engine mechanics basics are required. Now both are going to be a tensile load only. But if it is what now, here no doubt tensile. Sir, is it towards, sir, is a compressive. It is going away from the member, tensile load. It is also going away from the member. But most of students, they are going to take the compressive load, they are going to take it now. It is not a compressive load. Here nobody is going to get doubt, tensile load. If the question is given like this, they are going to take the plus 10. But here they are going to take a minus 10. But both are compressive, both are equivalent only. So what the axial load on this member now? Is a pure axial loading. Pure axial loading. Axial loads are applied at the extreme end. So what the axial load in AB in both the case now? So the extreme ends, don't see the water towards or away, toward the cross section. See away from the member or towards the member. It is going away from the member. It is also going away from the member. But at intermediate cross sections, then you check it. But at extreme end, directly see it what now? It is going away or towards now. Any doubt? Take a section. Some students, they don't have the proper basics now. Now you can check it. It is also tensile load. It is also tensile load. Both are going away. %30 of students, they are going to take the compressive load. Sir, towards B, sir, away from B. If this is clear, that is also going to be the same thing. It's going to be there now. Draw the free body diagram, my dear friend. If you want to visualize what now, draw the free body diagram. Cut it. AB member draws one member, BC member you draw one member, then you'll get it. Draw the free body diagrams. This already one of your friend, sir, I have already taken this as a compressive load. They are going to mention it now. Almost 50% they will take this as a compressive load. At extreme ends, don't see the towards the cross section or what now. Don't see it now. See going away from the member or towards the member. Otherwise take a section. Otherwise take a section. Here like this, sir, if the question is like this, what everybody is going to, sir, member is contracted, sir. If the question is given, what now? They will take this member is contracted, sir. It is what? Pushing towards right side, pushing towards left side. Therefore, length is going to be increase. It's also length increase. Here, nobody is going to get it out. Can you find out what the axial load, shear force, bending moment and twist moment at B? What the axial load, shear force, bending moment and twist moment at B? Determine axial load, shear force, bending moment at B. Most of the students they are going at B. They will write down axial load 0, shear force 30, bend moment is what now? 10. Somebody will write down plus 10, somebody will write down minus 10. And this also somebody will write down 30 and minus 30. And this is 0. Now if you ask what the bending stress means, directly what the M by Z, they will take this bending moment now. This is correct. It's the correct. But incorrect. It is a junction. This is not a, so many times I mentioned, it is not a bending moment, it is a bending couple. It is not a shear force, a constant at point load. Here you are going to get the two shear force, two bending moments. Here, one shear force and one bending because of extreme end. Directly this is a bending moment, directly this is a shear force. Now can you directly tell it now? At B, reactions are compulsory or optional? Reactions are optional. If you ask at B, reactions are not required. If you ask at B, reactions are optional. What you can do it now? Here, how many times you have to calculate the axial load? Only one time. When you have to calculate the axial load two times, if a one axial load is applied, you have to calculate the axial load two times. How many times you have to calculate twist moment? Only one time. Only one time. But shear force should be calculated two times and bend moment should be calculated two times. How to find out the axial load here now? Algebraic sum of the axial load either on the right side or left side. But I'm taking the right side because left side unknowns are there. When you can take the left side, if you have calculate the reaction, but I don't want to calculate the reaction. When at reactions are required now, if you ask at A, but if you ask at B, then directly take it at what now? Axial load at any cross section equal to algebraic sum of the axial load either on the right side or left side. But here you have to calculate only one time. Suppose one more axial load is applied now, then you have to calculate the two times. So right hand side how many axial load? No axial load. Directly answer is what? 0. But the shear force now? Two times. Shear force 2, shear force will be there two times. What is the meaning of two times? Neglect it. So what here directly I am writing now? So far previously explained now. Larger of shear force in BC AB. Larger of, first neglect this 30 now, neglect 30, take the right side. If you take the right side sign convert the right hand side sign convention for shear force, downward the positive. If you neglect it, right hand side, how many constant point load there now? For the shear force definition, algebraic sum of the constant point loads and neglected. Right hand side only one load is there. But what the right hand side sign convention, downward the positive. So this value is what? By neglecting or considering, no, neglecting the 30. 10. Then how to get second time you have to calculate. Second time. How to calculate the second time? Previous value plus considering this now. So what the previous value? Now 10. Previous value is 10. This here taken positive or negative? Positive. There is the upward. Both are in opposite direction. Now. Both are in opposite direction. Then it should be minus 30. Finally, what the larger value? No, minus 20. Means how it is distributed now. When B belongs to BC, what the value? No, 10. When B belongs to AB, what the value? No, minus 20. So this 30 kilonewtons distributed as what now? For BC member as what? A plus 10. AB member is going to be minus 20. I not written, just now I written now. Neglecting, I consider right side. Right side means use the right side convention, but the right hand side sign convention, no, downward is a positive. Next, previous value plus consider this value now. But since you have taken the positive, this is going to be upward direction negative. 10 minus 30, minus 20, minus 20. Next, what about the bendiment now? Bendiment. Here you are going to get the two bending couples will be there now. The two bendiments will be there. One bending couple. It is not a bendiment now. Two bendiments will be there. Once again the same method now. Neglect it. Larger of bendiment in BC. Bendiment in AB. Larger of, so neglect this bending couple, Now what the bendiment sign convention, what the bendiment definition now? Algebraic sum of the couples and moments. If you neglect it, left hand side couple is there or moment is, couple is there and moment is there. Assume this distance is what? 1 meter. Either 2 meters. If you neglect it, I'm taking the right side, I'm taking the right side. Right hand side, one couple is there, one moment is there. Now right side convention, but the right hand side sign convention, anti-clockwise a positive. Now this is anti-clockwise, anti-clockwise. Plus 20. One couple. Now the moment, what the moment due to this force here? Now 10 into 1. This moment is about a clockwise. Anti-clockwise positive means clockwise and negative. 20 minus 10 into 1. So what this value now? Plus 10. Means what the meaning of this now? When B belongs to BC, this is what a distributed as what? A plus 10. This is distributed as plus 10. Next. So what the previous value, how much I am getting now? Plus 10. Plus 10. Now consider this now. Consider. It is anti-clockwise, clockwise now. Anti-clockwise. Right hand side, what the sign convention? Anti-clockwise positive. This is anti-clockwise. So plus 10 and plus 10. 20. So how this is distributed now? For BC is distributed as a plus 10. Plus 10 means what? A sagging. Next for AB. For AB is distributed as what? A plus 20. So here how many bendiments are there? The two bendiments. For BC member the plus 10 and AB member is going to be plus 20. So what the larger value now? 20. But most of students are going to take the 10. If you take the right side convention, what the right hand side sign convention now? Anti-clockwise positive, clockwise and negative. Now this is what anti-clockwise positive, clockwise negative. 20 minus of 10 into 1. Right hand side one couple is there. What the Benjamin definition here now? Algebraic sum of the couples and moments. If you neglect it, if you neglect this value, right hand side one couple, right hand side anti-clockwise positive. And what the moment force into perpendicular, this moment is a clockwise. Since you have taken an anti-clockwise positive, clockwise and negative, 10 minus 1 plus 10. Then how to get the belongs to AB member? Previous value how much I'm getting? A plus 10. Then consider this couple is anti-clockwise, clockwise, anti-clockwise. You have taken anti-clockwise positive, right hand side, what the sign convention? Anti-clockwise positive. So previous value is plus 10 and this also plus 10, 20. So finally is what? A plus 20. And what the twistment? 0. Twistment should be calculated how many times now? Twistment should be calculated only one time. Suppose the twisting couple is applied, then you have to calculate the 2 times. But the twistment on the right hand side, there is no twisting couple. But the twistment definition, algebraic sum of the twisting couple. Right hand side, there is no twisting couple. Therefore, directly it is 0. Now, these are the answers now. Some friends are already given now. Somnath Mandal, axial load is 0, sir. Good. Shear force. Give the larger value. How you are getting? Shear force 20 and 10 you have written a larger value. Larger value is what? A minus 20. Shear force incorrect, Mr. Somnath. And bendment is also incorrect. Mr. Abhiday Sharma, shear force is minus 20. Kumar. Good. If those are not clear, just now what you have written, use the same procedure. Neglecting, constraint. That is just now done for axial load and twistment. Same thing, you can do it now. Most of the students, what the bendment means, what now? Sir, it's going to be a plus 10, they are going to do it. So I want to find out the bending stress at B. I have to take the plus 20, I have to take it. Plus 20, you have to take it. Still some students are not thorough with the sign convention. They have noted down, but they will not write the thorough with the sign convention. Till at the end of the last class also. So they are going to get it out. %, they will not, yesterday sir is not given any questions. They will not refer the class notes. They will refer the notes only when some questions are going to be given now. But I have already done yesterday some questions and what now? Some sign conventions are given now. Otherwise, what you have to do it now? What the other actual method now? Take a one section. Sir, I'm having a confusion. If you are having any confusion, what do you do it now? Take a one section in BC, one section in AB. Then you can write down now. But this will save the time now. Especially bendment case, what this method will take the. Otherwise, what you have to do it now? Yesterday you have done the same. At the end of the lecture, you have done it now. Yesterday I have done it now. What the actual method now? One section in BC, one section in AB. Then you have to write down the shear force and bendment equations now. If any doubts are there, please try to refer your axial load and fistment calculations. Somebody is asking, sir, why you are taking previous value? That I already mentioned, no? Previous, check it now. Somebody is asking, sir, why don't you take the what the moment due to this force here? No, 0. Somebody is asking, sir, why you are not considered the due to 30? This 30 is passing through B. Moment means what? A force into perpendicular distance. So what the moment due to this force at B? 0. I am calculating what at B itself now. This point, this load is passing through B only. This load is what? A passing through B. They will not get any moment now. Due to this 10 kilonewtons, are going to get a moment at C or other cross section now. Moment is what? A force into perpendicular distance. What the moment due to 10 kilonewton at C? 0. Due to 10 kilonewton, here you are getting a moment now. Same thing what? Due to 30, here moment is 0. Force into perpendicular distance. Suppose if I am calculating at A, then I am going to get a moment due to 30. If I am going to calculate at A, then you have to take the what? The moment due to 30. This 30 kilonewton passing through B, so it is 0. Yesterday I've already done, my dear friend. Please don't ask now once again now. Yesterday done about the same thing by taking a section now. If any doubt, take the sections. If any doubt, take a sections and you can do it now. Use any method, but if you take the sections, especially the bendment calculation, going to take the more time. So the bendiment or bending couple is a bending couple. But what the bendiment here now? When B belongs to BC, plus 10. When B belongs to AB, plus 20. Neglect, once again I'm explaining the bendment value now. First, I'm considering the right side. Considering right side means I'm assuming the B belongs to BC member. So first you neglect this value. If you neglect this value, what the bendment definition now? Algebraic sum of the couples and moments. Algebraic sum of the couples and moment. Right hand side one couple is there. Right hand side anti-clockwise positive plus 20. And what the moment now? Moment is force into perpendicular distance 10 into 1. Minus anti-clockwise positive means clockwise is negative. 20, what the moment due to this now? 10 into 1. So 20 minus of 10 plus 10. So when B belongs to BC, so this is distributed as what? A plus 10. Then how to get the when B belongs to AB? Previous value plus 10 plus 10. Then consider this bending couple. Previous value how much I am getting? The plus 10. Consider this couple, the anti-clockwise, clockwise, anti-clockwise. Already you have taken anti-clockwise positive. Right hand side anti-clockwise positive. So this should be taken as a plus 10. Previous value is 10. And couple at B. What the couple at B? 10. So 10 plus 10, 20. I have already shown, my dear friend, calculation. Check it now. Sir, is it correct? Means check it. You can already shown it now. If you are getting the same value, you're correct. If you are not getting the same value, means incorrect now. So those hearing any doubts, take a sections. Yesterday done it now. First thorough with the definitions, thorough with the sign convention. Bendiment is what most of they are going to make a mistake. Only bendiment. Bendiment is what not some of the couples. Bendiment is what now some of the couples and moments. Some of the couples and moments perpendicular to cross section either on the right side or left side. If you neglect it, right hand side one couple is there, one moment is there. Number of moments are equal to number of constant point loads. Sir, what about this now? This is passing through B. So there is no moment here now. Due to 30, you are going to get a moment at A, but at B 0. So right hand side 10 into 1. The moment due to this 30 kilonewton passing through B. Moment is the force into perpendicular distance. I am calculating at B. So there is no moment due to 30. Similarly, what the moment at C due to 10? 0. Any doubt, you can go for this method now. What is the time? This is the actual method, but the time taken now. If you ask objective question at B, whatever method I use, that only you have to use it now. If you use this one, it will take some time now. Now you can check it now. So this is valid for which portion of BC? What the X value now? 0 to 1. Now, can you write down what the axial load at this section? Axial load at XX, 0. I'm considering the right side, because right side only one load is there now. Shear force. Right hand side downward is a positive. Means is independent of X constant. Independent of X constant means B to C the constant 10. And what about the bendment equation now? What the bendment equation now? Plus 20. What the sign convention the right side downward is a positive. We are taken on the right side downward is a positive. 10 into X. What the right hand side sign convention? Anti-clockwise is going to be positive. No twisting couple. Now I'm interested B. At B what the X value now? I'm interested in B. At B what the X value now? 1. So if you want to get at B, if I substitute X is equal to 1 in this above equation now, what the bendiment now? If I put it X is equal to 1, So check it, previous one I have written the same now. So when B belongs to BC member, shear force 10 and bend moment is 10. Next. AB member. AB member take a section now. But here better to consider which side now. Left side is better. Because right side, how many loads are there now? 2 constant point load, 2 couples are there. Somebody can also take the right side. But to simplify, always better take the left side. But if you want to take the left side, reactions are required. First you find out the reactions. So I'm taking the left side. X. If you want to take the left side, those who want to take the right side, you can do it now. You can do it, but I'm taking the left side because left side is what now? Least loads are there. Now can you find out the reaction? What the vertical reaction here now? 20 downward. 20 downward. And what about the moment reaction? What the moment reaction? Find out the net moment at A. 30 into 2 anti-clockwise. 30 into 2 60. This is what now? 20. 80 anti-clockwise. This is also what a 10 90. So it will be a 60 will be there now. Most of them are going to make a mistake in the reaction, the moment reaction. How to find out the moment reaction? Find out the net moment at A. What the net moment at A? Minus 10. Anti-clockwise I'm taking negative. 30 into 2. Next, minus 20. Next, 10 into 3. What this value now? Minus 10, minus 60, minus 70, and this is minus 90. So you are getting minus 60. What the meaning of minus 60 now? Anti-clockwise. We are used about what the sign convention I used it now. Anti-clockwise I taken negative. Anti-clockwise negative. Then what should be the moment reaction now? Moment reaction should be minus means opposite direction. Since the anti-clockwise, then it should be clockwise. So what the sign convention I followed here now? Anyone can use it now. I take an anti-clockwise negative. Somebody can take the anti-clockwise positive also. You can consider it now. That's all. Now can you write down AB? AB. What the shear force now? Right hand side only one load. So left hand side only one load. Left hand side what the sign convention? Left hand side sign convention is what now? Negative. Downward is positive. So downward is negative. Upward is a positive. So what the shear force now? So what the limits here now? X is equal to 0 to 2. Left hand side there is no twisting couple and there is no axial load. Both are 0. What the shear force now? Left hand side what the sign convention? Upward is positive, downward is a negative. So the minus 20 is a constant. Here I taken on the left hand side. What the left hand side sign convention? Upward is positive. Left hand side upward is positive. What the bend moment now? Sum of the couples and sum of the moments. Sum of the couples and sum of the moments. And what the left hand side sign convention? Clockwise is positive. Anti-clockwise is going to be negative. couple clockwise a positive. What the sign convention in the left hand side? Clockwise a positive. That's all. Now I want to get at B. At B means what the value? Now B means what the x value? Now 2. So substitute the x is equal to 2. Minus 20. Minus 20. Then what about the bendiment now? Now check it now. So finally what the shear force at B? This is what when B belongs to BC, how much? Not 10. This is what when B belongs to AB, minus 20. What the larger value? Now minus 20. And what about the bendiment when B belongs to BC? Plus 10. When B belongs to AB, how much? Now 20. This only got it now. But this much of time is going to take it now. Most of the students are going to use this method now. This is the actual method. But in objective examination, if you use it like this, what do you mean? Get an answer. The friends who has followed my method now, they are going to complete the question within 1 minute now. But those who are going to follow this one now, then they will take the 10 minutes time. If you take the lengthy process now, chance of what the drawback if you take a lengthy method now. One drawback is what now? You may get a correct answer, time is wasted. And what the another drawback now? Chance of committing the mistakes is more. When you want to reach your final destination, you can reach your what now? From your residence to your institute. You can reach 10 ways you can reach it now. But always which one you are going to select? The shortest route. If you select the shortest route, what happens now? It will take the less time and you will reach the final destination within a less time. And there is no confusion. If you have taken a longest route, what happens now? It will take the more time, more fuel consumption. Then you are going to get a confusion. Which turn I have to take it? Left turn or right turn? There are so many confusions are there now. Then definitely sometimes you will not reach your final destination after wasting half an hour time. You will reach what or some other institute. You will not reach your final institute now. If you enter the other institute, they will not permit you now. So always you have to select the best route is about a route which is going to reach your final destination within a less time with less confusion. Same thing here also about now. Always you should be thorough with all the method, but as per the question you have to select a best method now. Now you can see this much of time, but in the previous case directly get got the answer. Answers are same. So finally what the bendiment B? What the larger of these values now? This is when B belongs to AB. This B belongs to BC. What the larger value? Now 20. And what the shear force now? What the larger value? Now 20 minus 20. Check it what previously also got the same value or different values now. I not done yesterday, already done it, but somebody is asking now, sir, can you explain with the first method? Yesterday already done it now. How many times I am going to explain it now? Yesterday I done the same thing. Yesterday check it now. Same question here done it now. If you take the right side, use the right side convention. If you take the left side convention. But the left hand side sign convention for shear force upward is positive. Bendiment is clockwise is positive. Right side downward is a positive shear force. And bendiment is anti-clockwise positive. But they will not thorough with the sign conventions now. Bendiment at C is what? A plus 20, my dear friend. How it is a minus 20? Sinha. How is the minus 20? This is the plus 20. Is the right side anti-clock is a positive. Sir, benefit C is what a negative you are telling now. एक बार देखो साइन कन्वेंशन देखो, आपको कल टाइम नहीं मिला तो एक बार नोट्स देखो, साइन कन्वेंशन देखो, पूरा लिख लिया था मैंने, ग्राफिकल रिप्रेजेंटेशन दिया था और स्टेटमेंट्स में भी दिया था बेंडमेंट साइन कन्वेंशन का. These two are positive. Left hand side clockwise positive, right hand side anti-clockwise positive. इतना बार बोलने के बाद भी आपने सर ये नेगेटिव है सर बोले तो मैं क्या करना है? No, it's up to you now. Whether you want to follow this method, you can use it now. So many times I mentioned, if you want to get a success in the GATE examination and ESC, getting the answers are not criterion. Getting the correct answer within a less time. Getting the correct answer within a less time is a very important now. Time is very, very important. So to get a success, you should behave like a flywheel. Flywheel. This going on what now? Toward the top or bottom now? Anti-clockwise, going toward the top. Top contraction is a positive. How it is a negative, my dear friend? Sorry, bottom. This is what are going on the bottom side. This is a clockwise means what are going on the bottom side. Is a anti-clockwise. This is a anti-clockwise. Anti-clockwise means what are going toward the top. Top surface contraction. Is anti-clockwise, going toward the top. But this is clockwise. This is going toward the bottom. So now we have completed very, very important topic, that is what now? Loads on the cross section. We can apply 6 loads. They are equal to only 4 loads. So overall on the cross section in any condition, maximum loads are possible are 4. Axial load, shear force, bendiment and twistment. Every eccentric axial load equal to 1 axial load and 1 bending couple. And TSL equal to 1 shear force and bendiment. And ETSL equal to 1 TSL plus 1 twisting couple. And due to TSL, once again is shear force and bendiment is there. Then, because the maximum loads are axial load, shear force, bendiment and twistment. Then you have studied how to find out the axial load, shear force, bendiment and twistment. What the general method you are given now? Equivalent load at any cross section equal to algebraic sum of the corresponding load either on the left side or right side if the member is horizontal. Algebraic sum of corresponding load means in case of axial load you have to take the sum of the axial loads. Shear force means sum of the consonant point loads. Twisting means sum of the twisting couples. Only in bendiment case you have to take the sum of the moments and sum of the couples perpendicular to cross section. Then you have studied the sign convention. Axial load sign convention simple. If they are going away from the cross section, it's going to be what now? Either positive. But extreme ends simply see the what they are going away from the member or towards the member. Extreme ends simply see what are they going towards or away. Towards or away from the member. Towards the member means a negative. Away from the member is going to be positive. Then once you know the twistment's axial load sign convention, twistment is remains same. Convert the semi-closed ellipse into a double arrowhead by using the right hand thumb principle. Generally mostly you are coming across about horizontal member. For horizontal member, clockwise means double arrowhead is going to be towards left side. Horizontal member twisting couples are in profile plane. So whenever a twisting couple is in a profile plane, clockwise means double arrowhead towards left side. Anti-clockwise means double arrowhead is going to be towards right side. Once again, what now? Is the positive simply opposite to axial load. Extreme and see that double arrowheads are going away from the member means is a negative. If the double arrowheads are coming towards the member, it's going to be positive. Simply opposite to axial load. But when you are calculating intermediate cross section, then you check it what now? Toward the cross section is going to be positive, away from the cross section is negative. Then what the shear force sign convention? If the shear force on either side, if they form a couple in clockwise direction is positive, anti-clockwise direction is going to be a negative. But mostly in case of beams, what the sign convention? Mostly beams are loaded with a VTSL. In that case, what the sign convention? Left hand side upward is positive, automatically right side downward is positive. Left hand side upward means right hand side should be downward. Vice versa. That is left hand side downward is negative, right hand side upward is negative. Then what about the bendiment now? If the couples are going toward tops, when the top surface gets contraction is a positive. Backside surface contraction is a positive. Left side contraction is positive and vice versa. But in beams, what the sign can miss? Beams are mostly horizontal member under VTSL. Vertical bending will be there now. In that case, what the sign convention now? Left hand side clockwise is positive. Right hand side anti-clockwise positive. Both are positive. But this sign convention, when I have to use it now, when I am taking the sum of the couples and moments on the left side. This you have to consider when you are counting the sum of the couples and moments on the right side. And vice versa. Left hand side clockwise positive means left hand side anti-clockwise negative. Right hand side anti-clockwise positive means right hand side clockwise is negative. And at extreme ends, directly the applied axial load will become the axial load at that cross section. The constant point load at extreme end will become the shear force at that cross section. Bending couple at the extreme end will become directly the bendiment at that cross section. Twisting couple at the extreme end will become directly twistment at that cross section. So whenever you want to get a twisting moment at the extreme end, one twisting couple is required. To get a bendiment, one bending couple is required. To get a shear force, one constant point load is required. To get an axial load, one axial load is required. But at the junction, that is the intermediate cross section. When an axial load is applied at a junction, there are two axial loads is there. Then what the axial load junction means, 2 times you have to calculate. One section in AB, one section BC, larger value. Otherwise, what the method na shortcut na? First, neglect that axial load. Calculate axial load on one time by taking either on the sum of the axial load on the left side or right side. First, you can calculate the axial load by neglecting that applied axial load at that junction by considering algebraic sum of axial load either on the left side or on the right side. Then you calculate one more time axial load. You calculate one more time. First you have to neglect it, you have to calculate the one time. And second time, one more time you have to calculate by considering that applied axial load. Same thing. Then finally, which are the larger, that will be the axial load at that cross section. Similarly, when a constant point load is applied, then you are getting the 2 shear force. Then once again, same method now. To get a shear force, what do you have to do it now? First, neglect that constant point load, calculate the shear force one time. Then you consider that constant point load, calculate one more time. Finally, which are the larger, that the shear force now. Next, bending. When a bending couple is applied at a junction, when a bending couple is applied at a junction, 2 bendments will be there. Then how to get a bendiment? Now first you have to neglect that bending couple, calculate the bendiment by considering the sum of the couples and moments either on the left side or on the right side. Then calculate the bendiment one more time by considering that bending couple. By considering that bending couple. Then finally, which are the larger? The same thing you have to do in case of twisting case now. So whenever an axial load is applied to junction, 2 axial loads. Whenever a twisting couple is applied, 2 twistment. Whenever a bending couple is applied, 2 bendiments. Whenever a twisting couple is applied, 2 twistment. And when a constant point load is applied, 2 shear force will be there now. So if you ask at the junction, either you can take the 2 sections, you can calculate now. Otherwise, first neglect that load, calculate one time, then consider that load, second time you calculate, finally which are the larger. So it's up to you now. This is what the summary, whatever you have studied now. So once you determine these loads now, simply remaining is what directly substitution in the equation. Axial stress equal to written now. Stress on any cross section equal to stress on any cross section, numerator what a corresponding load. Axial stress means axial load. Bending stress means bendiment. Torsional shear stress means twistment. Direct shear stress means shear force. And denominator corresponding geometrical property. Corresponding geometrical property. Axial stress means directly area, denominator. Maximum bending stress means denominator section modulus. And maximum torsional shear stress means polar section modulus. So once you did, always in the question, which one is given now? Circular cross section is given, area is known, pi d square by 4. And what the moment of inertia? Pi by 64 d to the power of 4. What the section modulus here at now? Pi by 32 d cube. And what the polar section modulus now? Pi by 16 d cube. So you know, once you know the shape of the cross section is given in the question, you know the geometrical properties. Now only the student has to calculate only axial load, shear force, bendiment and twistment. That's all. So this comes under what now? A prismatic bar under pure axial loading. Already starting here discuss. When you are going to get a pure axial loading, now so many times I discussed now. Whenever you want to get a pure axial loading, two equal and opposite axial loads are required at the extreme end. Pure axial. What is the meaning of pure axial load? You have studied now. Pure axial load means at every cross section only axial load. ALD will be a rectangle. SFD, BMD, TMD are the line cones 0. So on the cross section you are getting only axial stress. Here only you have studied the equations are what now? Axial stress equal to P by N, change in length equal to PL by AE. On every cross section how many loads? Just now you have studied 4 loads. Pure axial load means on every cross section you will get only axial load. Shear force, bendment and twistment 0. Means on all the cross section you are getting only axial stress. Means on all the cross section which one is 0 now? Shear force 0, bendment 0, twistment 0. Means bending stress 0, torsional shear 0 and direct shear stress 0. Only axial stress is there. But whenever you want to get a pure axial load, what the condition now? Pure axial load is possible only when two equal and opposite axial loads are applied at the extreme end. Same thing for the pure bending now. When you apply the two equal and opposite bending couple at the extreme end. Two equal and opposite bending couple at the extreme end. It is the pure bending. Similarly, when two equal and opposite twisting couple applied at the extreme end, the pure torsion. This already you have studied. This is the first chapter now. Somebody will ask now, how does the pure axial load mean? What the answer? No, take a section. Take a section, write down the load. If I take a section here now, what the axial load plus P? Is independent of X or independent of X? But the shear force 0. Whenever you want to get a shear force, at least one constant point load is required. And to get a bendment, at least one bending couple is required. So what the, sir, somebody will ask, sir, how do you know pure axial loading? Can you prove it out? Take a section, write down the loads. If you take a section here, now right hand side, I'm getting only axial load. Remaining 3 loads are 0. It is a pure axial loading now. So whenever you want to get a pure axial loading directly, what the condition now? At pure axial load is possible when you apply the two equal and opposite axial load at the extreme end. Now what this two will form now is eccentric axial tensile, eccentric axial compressive. Then this will form a bending couple. So here you are getting only bending couple. What the direction of the bending couple now? Clockwise. And this couple is a CX or CY or CZ, CX. Then you have to take the moment of inertia and section modulus about XX. Is a clockwise. Clearly mentioned. Whenever you want to get a bending couple only on the cross section. You want to get only bending couple on the cross section. Then you have to apply the what now? Two equal parallel opposite eccentric axial loads. Now pure bending means what now? This couple is a clockwise, anti-clockwise, clockwise. Pure axial load means what? Two axial loads of equal magnitude, opposite direction. Similarly, pure bending means what? Two equal and opposite bending couples. Now this is a clockwise, anti-clockwise, clockwise. Then here you need an anti-clockwise now. Now these two will form a bending couple in which direction? Anti-clockwise. Either clockwise. Therefore it is going to be what now? Sagging or hogging? No, sagging. Pure sagging bending. Means at every cross section you'll get only bending. Remaining three loads are zero. That is what axial load, shear force and twist moment zero. Here only your bending equation valid. What the bending equation now? M by I equal to sigma by equal to E by R. Bending equation, chap number 5 is derived about a bending equation derived under pure bending. What this line now? Top surface is the top surface, bottom surface. This line is the top fiber, bottom fiber, front fiber, this is the back side fiber. This total line is about the top surface, bottom surface. This line is the cross section. Cross section is the shape of the cross section. So this line is the top fiber, bottom fiber. This is the front side fiber. This is the back side fiber. Is the which side view now? Left side view. Left side view is drawn on the right side. The all each and every basics explained. This is the left side view. So this will be about now front fiber. This is the back side fiber. So now this will come under pure bending. Now these two will form a what now? Shall I go for arc of circular semi-closed ellipse now? Arc of circle. These couples are in which plane? Vertical plane. Cross section in profile plane is a bending couple. Now this couple is what? A vertical plane which acts as perpendicular x. Therefore Cx, that is the mx. What the direction now? Means I take the moment of inertia and section modulus about x. Now x means what? Xx means this couple is about which acts now? HCA. So section modulus and moment of inertia should be taken about HCA. Now these two will form a anti-clockwise. So this is a pure bending. What is the meaning of pure bending? Axial load 0, shear force 0, twist moment 0, only bending. How do you know it means what? Take a section. If I take a section here now, if I take a section, what the axial load on the left side 0. Whenever you want to get an axial load, one axial load. And what the shear force? 0. To get a shear force, one constant point load is required. And what about the twistment? To get a twistment, one twisting couple is required. And left side you are getting only couple. What the bendment now? Left side I am getting a couple or moment, only couple. There is no moment. When you are getting a moment now, to get a moment there should be a constant point load required. Therefore you are getting only bendment, positive. So what the bendment here now? PD. Independent of x or depend upon x? Independent. Means at each and every cross section you are getting a constant bendment. And the positive or negative, the top surface is the top surface. Now what this line is cross section. This is a cross section on which side now? Left side. Is a cross section on the right side. This couple is a clockwise, anti-clockwise, clockwise. So this will rotate in clockwise direction. This will rotate anti-clockwise. Then top fibers have come nearer. So length at the top is decreased. Length at the bottom is increased. Therefore top we are getting a concave is upward now. Then the sagging. This overall is called about a pure sagging bending. Pure sagging bending. So here bending equation valid. So this what this figure representing now? A prismatic member under pure sagging bending. So you are getting only BMD. Only BMD. So here only your bending equation valid. M by I equal to sigma B y equal to E by R. This is chapter number 5. These two are what? ETSL. ETSL outward, ETSL inward. Now these two will form a twisting couple. Twisting couple in which plane? A profile plane. So seeing from the right side, it is the anti-clockwise. Then double arrow is going to be towards right side. This is what now? ETSL inward, ETSL outward. Now this will form a couple in which plane now? Profile plane clockwise, profile plane clockwise. Then double arrow is going to be towards left. Here towards left, here towards right. With a pure torsion. Either clockwise direction, anti-clockwise direction. Here I taken what a circular. Why now? Because your torsion equation valid only for circular. Only you're having the syllabus of torsion of circular. But that equation, bending equation, axial loading equation valid for any cross section. But your BTEC syllabus having only a torsion of circular. That's why I taken the circular here now. Starting when I discussed the pure axial load, this was explained, but I not shown the diagram because by that time you are not discussed the bending and twisting up. Those you have tried to recollect it. When you are studying the starting now, axial, pure axial load clearly mentioned now. Pure axial load means you have to apply the two equal and opposite axial load at the extreme end. Means at each and every cross section you are getting only axial load. Only ALD will get it. Shear force and bendment and twistment is 0. Then at that time sigma A equal to P by N, change in length equal to PL by AE. And for that equation, how many conditions here written now? First of all, should be a prismatic, pure axial loading and same material. Same thing what a pure bending means, you have to apply the two equal and opposite bending couple. But these bending couples cannot be applied. Bending couples are formed due to what now? Two equal parallel opposite eccentric axial loads. Here only bendment is there, only BMD will be there. Axial load, shear force and twistment is 0. And pure torsion means you have to apply the two equal and opposite twisting couple. But the twisting couples are formed due to two equal parallel opposite ETSLs. Now this is what now? Top one is the away, bottom one is the inward. So this is a clockwise, anti-clockwise, seeing from the right side, anti-clockwise. Is it CX or CY or CZ? Is in which plane now? Profile plane. Profile plane which axis is perpendicular Z. Therefore it is CZ. Now your top one is the inward, bottom one is the outward. Top one is the inward, bottom one is the outward. So this is a clockwise. Clockwise means double arrow towards left side. Here towards right side. Is the pure torsion. So this is chapter number 6. Torsion equation derived as assuming what now? A prismatic member and a pure torsion. Whenever you want to get a pure torsion, two equal twisting couple should be applied in the opposite direction. If that is clear, the same thing now. Is anti-clockwise. Anti-clockwise means double arrow is going to be towards right side. All our interconnection will be there now. Now take a section. How do you check it? Is it pure torsion or not? Take a section. If I take a section, what the axial load? 0. Shear force 0. Bendment 0. What the twistment? Plus T. It's the pure torsion. Means independent of X. Means at each and every cross section you are getting only twistment. And the twistment magnitude and direction is same. Only you are going to get a torque diagram, you are going to get it. Now here this figure is representing what now? is the ALD. What is the shape of the ALD rectangle? What is the meaning of rectangle? At each and every cross section is what now? Axial load, magnitude and direction is same. This is possible only when you apply the two equal and opposite axial loads. What these dots are representing? What this dot is representing now? Centroid of the cross section of the left side. This is the centroid of the cross section of the right side. So all these dots are representing the cross sections only. So at each and every cross section, what the height now? PP. So these are all representing the what now? This represents the longitude axis. What is the longitude axis definition now? Imagine line joining the centroids of each and every cross section. So what this dot is representing now? This cross section represented by this centroid. This cross section represented by centroid. So each and every cross section represented by centroid. Means that every cross section axial load, magnitude and direction is same. Next. Means shear force. From the cross section, how many loads you have studied? 4 loads. Maximum loads are 4, but here getting only 1 load. How many stress you have studied? Axial stress, bending stress, torsional shear, direct shear. Now here getting only axial stress. So what this overall figure is representing now? A prismatic bar, PB. PB means prismatic bar. A prismatic bar under default material is same. A prismatic bar means each and every cross section dimensions are same. Made of same material under pure axial loading. Somebody what? How do you know it? What shear force and bendment and twistment are 0? Take a section, I can prove it now. If somebody will ask, how do you know shear force and bendment 0? Directly what the answer now? So to get a shear force, at least one constant point load is required. Since there is no constant point load, shear force 0. To get a bendment, at least one bending couple or a constant point load is required. Since there is no bending couple, no constant point load, bendment 0. And to get a twistment, one twisting couple is required. Since there is no twisting couple. Otherwise, you can use the take a section now. Now what the axial load plus P? Depend upon X or independent of X? Independent. Constant. What the shear force 0? Bendment is 0, twistment is 0. So what the conclusion now? Whenever you want to get a what now? Remember the pure axial loading means you have to apply the two equal and opposite axial load extreme end. And what the next conclusion, you can see it now. Here one axial load. Now axial load will remain constant until next axial load. After A, where the next axial load is applied, now B. So between two axial load, axial load magnitude and direction is constant. Between two axial loads, axial load magnitude and direction is constant. Same thing what between two constant point loads, shear force and magnitude and direction is constant. Similarly, between two bending couples, bending magnitude and direction is constant. Between two twisting couples, twistment magnitude and direction is constant. Always after A, where the next load is applied, B now. So from A to B, axial load is a constant, magnitude and direction. So between two axial load, magnitude and direction is constant. So for this only what the equations now? But these are all representing on the cross section only. So these are all what now? Axial stress, bending stress, torsional shear stress, direct shear stress, they're all on the cross section. They're all on the cross section only. But if we ask what the maximum shear stress in the bar, maximum shear stress in the bar is what now? Half of P by A. They're all representing only on the cross section only. Axial load, shear force, bendment and twistment on the cross section. So if you ask on the cross section which stress 0 na, shear stress 0. But if you ask in the bar means what is the uniaxial state of stress, directly this will become the principal plane because there is no shear stress now. Cross section will become the principal plane. So what is the uniaxial state of what the maximum shear stress now? Half of P by A. Which stress are 0 now? Bending stress 0, direct shear stress 0, they are all representing what now? Axial stress is a stress on the cross section, is a stress due to axial load on the cross section. Bending stress due to bendment is also on the cross section. What the bendment now? Algebraic sum of the couples and moments. Bendment at any cross section what now? Bendment at any cross section equal to algebraic sum of the couples and they're all on the cross section. All what are all the equation representing now? They're all representing so try to differentiate it now. So how many normal stress now? Two normal stress, two shear stress. These two can be added, these two can be added. But in our case, which one is there now? Only axial stress. So they're all on the cross section only. But we ask in the member means what now? In the member means shear stress 0 or non-zero. Non-zero, what the maximum shear stress? Oblique plane concept now. Stress is defined at a cross section or at a point. Stress is defined at a point. At a point, infinite planes are there. So on the cross section, shear stress 0. But in the member means what the maximum shear stress? Half of P by A. So whenever you want to use the equation, what the condition now? Whenever I want to use the equation, what the conditions now? First of all, it should be a prismatic. Next, pure axial loading, PAL. Want to write down full name now? Pure axial loading. Next, same material. So whenever you want to use the equation, first of all, it should be a prismatic bar. If a tapered bar is given, we cannot use it now. It should be a prismatic bar. Next condition is what now? Pure axial loading. Means at every cross section, axial load and magnitude should be constant and same material. Then only well. If any of these conditions are not satisfied, directly we cannot use it now. Probably already written these conditions. At which angle you are getting now? This is at an angle of 0. Cross section means x face. This is at an angle of 0. This is what at an angle of 45 and 135. That already you have studied now. So you should be careful whether they are asking the what now? Axial bending, torsional shear, direct shear stress means they are all on the cross section. But if you ask in the member means you have to use the principal plane concept is required now. In the member, that only you studied now. So now this will come under what? A pure bending. Pure bending. So here how many diagrams are possible now? What the difference there now? There two equal and opposite axial loads are applied. The pure axial loading. Similarly, when you apply the two equal and opposite bending coupled at the extreme end, pure bending. But the positive or negative, left hand side clockwise a positive, right hand side anti-clockwise positive, otherwise take a section. It's not required directly, can tell it now. As long as what when you apply the two equal and opposite bending coupled at extreme and pure bending, means at every cross section you are getting only bendiment. Then BMD will be a rectangle. Same concept now. Then shear force, twistment and axial load are 0. But how do you know the pure bending means? You have to take a section. So what the axial load now? 0. To get axial load, at least one axial load is required. Shear force 0. To get a shear force, one constant point load 0. Twistment, two twisting couple is 0. But this bendiment is positive or negative? What the bendiment now? Algebraic sum of the couples and moments. Left side only couple is there. There is no moment now. When you are going to get a moment, there is a constant point load is required. So here, is independent of x means a constant. That's why the pure bending. So on every cross section which load is there, no, only bendiment. Means on every cross section which stress 0, no, axial stress 0, direct shear stress 0 and torsional shear 0. But once again in this member, shear stress is not 0. Everybody is going to tell what now? Shear stress what? On the cross section 0. These are all on the cross section. On the cross section shear stress 0. But in the beam, in the member means is non-zero. Now the positive or negative? Positive sagging bending. Is a very standard question. Yesterday I already mentioned. Under pure bending, shear for positive, negative, 0. Either positive or negative. What the answer? No, 0. So when you are going to get a pure bending, now when you apply the two equal and opposite bending coupled at the extreme end. This line along it acts, these are all the centroids. BMD. BMD is positive mean what? Sagging. What is the meaning of sagging? The top surface gets contracted. Top surface gets contracted, bottom surface is going to be elongated. Top surface gets contracted, bottom surface is going to be elongated. Top surface so length at the top is decrease or increase? No, length at the top is decrease. Bottom length is going to be increase. When the length at the top is decrease means strain is at 10, compressive strain. Length is decrease means what? A change in dimension to original dimension, the normal strain. So what the normal strain at the top now? Compressive. When the strain is negative means stress is going to be compressive. So what the stress at the top now? Compressive. But what about the stress at the bottom? Length is increase. Length is increase means what now? Longirular strain is going to be a tensile. When the strain is a tensile, stress is a tensile. So here you are going to get a tensile or compressive. Both are going to get it now. But in this case, what happened now? Total member is elongated. Total member is elongated. Means everywhere the strain is tensile. Is axial load. Here length is going to be increased. Means everywhere what a length is increased means what a strain is a tensile. Then stress is a tensile. You are getting only tensile stress because of tensile load. But here what happens now? Top surface gets contracted, bottom surface elongated. Top length is what? A decrease means strain is compressive, then stress is compressive. Bottom surface elongated. Elongated means what? A length is increased. Strain is a tensile, stress is going to be a tensile. Shear force, bending and axial load is 0. Mean which stress 0 na? Direct shear 0, torsional shear 0, axial stress 0. Only bending means on the cross section you are getting only bending stress, normal stress. But in the beam what na? In the member shear stress is not 0 na. On the cross section is 0. So what this overall member figure is representing now? A prismatic beam under pure bending. Pure sagging bending. Pure sagging bending. Axial load, shear force and twist moment are 0. Directly I'm writing the equation. This is what now? So this is a bending equation. This bending equation what now is derived in the chapter number 5, assuming pure bending. This equation valid in this case only. M is about a bendiment. I should be considered about neutral axis. But how to decide the neutral axis now? Couple is acting about which axis now? X. So directly this xx will become the neutral axis. So many times I mentioned you have to take the moment of inertia and section modulus about which axis now? About which axis the couple is acting. This couple is acting about which axis now? X. X means which axis now? HCA. So this will become the neutral axis here now. Directly this will become the neutral axis. For the neutral axis you are going to study, but time being both now. Directly how to decide the neutral axis, about which axis the couple is acting, about which axis the couple is acting. The couple is acting about x. Suppose this is what a couple is in horizontal plane. Then this is about yy. Then yy will be the neutral axis. How to identify the neutral axis? Directly I written xx because of what now? This couple is about xx. But in horizontal bending, these couples are in horizontal plane means about which axis now? Yy. Then I have to take the Iyy. That only yesterday in case of bending, section mod, moment of inertia, section modulus should be considered either about HCA or VCA. But this is what now? Vertical plane means about HCA. HCA means XX. In case of horizontal bending, you have to take it about VCA. So this equation is going to be chapter number 5. Chapter number 5. Bending equation is valid under pure bending. Pure bending means what? Shear force 0, twisting 0, axial load is 0. Bending is constant, but that is possible when you apply the two bending couples in the opposite direction. And from this only your bending equation, you are going to get it a bending stress. A is equal to B is equal to C. This is the A, B and C. Now what the A value now? A is equal to B means what now? What the sigma B? Sigma B equal to my by I. My by I. When you want to get a maximum bending stress, I have to take the Y max. By equating A and B, what the sigma B? My upon I. But if you are interested in maximum bending stress, if you want to get a maximum stress, then what should I write now? My max upon I. That I by Y max only are called as the section modulus. For the maximum bending stress equation, my max upon I. And the I by Y max only nothing but you are called as a section modulus. Then you are going to get the maximum bending stress equal to M by Z. Maximum bending stress equal to M by Z. That Z should be taken about the neutral axis. And what the other way can find out the bending stress? You can equate these two now. What the other one now? Sigma B equal to Ey by R. A is equal to B is equal to C. So by equating A and B, what the bending stress now? My by I. By equating B and C, what the sigma B? Ey by R. So you can find out the bending stress two ways. My by I, Ey by R. If you want to get a maximum bending stress, you have to go for Y max, you have to take it now. Exact definition of neutral axis I'm going to decide it. But timing what about how to identify the neutral axis? Identify the couple is acting about which axis? Couple is acting about xx. So directly xx will be the neutral axis. Xx will be the neutral axis. So in case of vertical, it is a vertical bending. These are in which plane? Now vertical plane. Vertical bending. So in case of vertical bending, directly which is the neutral axis? HCA. Horizontal bending, VCA will be the neutral axis. Now, can you show the deformed shape here now? For the deformed shape, yesterday what you have studied now is the top surface, bottom surface. All are having, how many surfaces are there? Infinite. Top, bottom, in between how many surfaces are there? Infinite. All the surface having the same length. As long as there is no load applied. And these cross sections are parallel or non-parallel? Parallel. Parallel. But after applying the couple, what happens now? This couple is a clockwise, anti-clockwise, clockwise. So this cross section will rotate in the clockwise direction. What this dot now? Top fiber, bottom fiber is also cross section. Top fiber, bottom fiber. What this total line? No, top surface. What the top surface you have studied now? A surface joining the all the top fibers. Surface joining the all the top fiber of every cross section. Is the top fiber of cross section on the left side. Is the top fiber of cross section on the right side. That is what this line. Fibers can be seen in the plane of cross section. Now, this couple is a clockwise. Therefore, this cross section will rotate in the clockwise direction. And this will rotate in the anti-clockwise direction. Therefore, this T will go towards left side, the right side. This will come left side. Therefore, top fibers have come nearer. And this B go which side now? Left side. And this will go right side. So, bottom fibers goes far away. This rotated clockwise. Means this top fiber goes towards right side. This rotated anti-clockwise. So this top fiber come towards left side. So top fibers have come nearer. Means length at the top is decreased. Means it will bend in the form of a circular arc. It will bend in the form of a circular arc. What is red color line now? Cross section the left side after applying the bending couple. Now this is the top fiber. T dash. And what about this cross section? This rotate in anti-clockwise direction. Now this top fiber, both are coming nearer. So length at the top is going to be decreased. So it will bend in the form of what now? It will bend in the form of a circular arc. Is a concave or convex? No, concave. This only are called as what? Sagging. And length at the bottom is increased. Length at the bottom is increased. Length at the bottom is increased. So your strain is what now? Length is decreased means what? A strain is a negative, compressive. Here length is increased means what? A longer strain is going to be positive. So when the strain is negative means stress is negative. Here strain is positive means stress is also going to be positive. So what the stress at the top now? Compressive. stress at the bottom is going to be here negative. Stress is what a compressive. Here stress is going to be positive. And what about this blue color one now? What about this blue color one? Neutral surface, whose length will remain same even after bending. Initially, all the surface of same length are what now? Top is 100, bottom also 100, in between also 100 now. Assume this length is 100 mm initially now. Length at the top is 100, bottom is also 100. Assume this length is after applying the bending couple is 96. This length is what a 96. Means how much is decreased now? 4 mm is decreased. 4 mm is decreased. And here length is increased by 4 mm now. This is 104. Here length is what a 96. Here length is what now? 104. Then what happens now? Next surface what you are getting now? 97, 98, 99, and somewhere you are going to get 100. Next 101, 102, 103, 104. And what about this blue color line now? Where length will remain same. After applying the bending couple, before applying the bending couple, same. So this is called the neutral surface. Neutral surface is a surface whose length remains same even after bending. So what the strain here now? Change in length is 0, therefore strain is 0, the stress is 0. So at the neutral surface, stress is 0. So change in length is different or changes now? Here change in length is more now. More contraction. More contraction means what now? More compressive strain and more compressive stress. And here you are getting what? A more increase in length. Means more tensile strain. More tensile strain means what? A more tensile stress. That's why bending stress always maximum at the what now? Top and bottom. Or the fiber far away now. So fiber to fiber, what happened now? Change in length is same or different now? So they're all bent in the form of a circular arc. They're all circular arcs. They're all what now? Concentric circular arcs. Now concentric means center is same, radius is different. So under pure bending, every surface will bend in the form of a circular arc. And what the shape of the circular? Concave or convex now? Concave. This only you call it about the sagging. And this blue color is what a neutral surface. So every surface will bend in the form of a circular arc. This is possible only under pure bending. But they're all having the same center or different center. Center is same. They're all concentric circles. Concentric circle means center is same, radius is different. So this is called as what now? Capital R. So what this capital R here now? Radius of curvature of neutral surface. Radius of curvature of neutral surface. All they having the same radius or different radius? Different radius. They're all concentric circles. Center is same, radius is different. So this R is called as what? A radius of curvature of neutral surface. Neutral surface. What is blue color one now? Neutral surface. Neutral surface. I'm the short form of NS. NS. And this shape is possible only under pure bending. This shape is possible only under pure bending. Pure bending means what? Only bendment, remaining loads are zero. And when you are going to get a pure bending, when bending couples are applied now, bending equation derived now. Bendment diagram is positive, means sagging. Stress is not positive now. Bendment diagram is positive, means sagging. Sagging means top surface is a contraction, bottom surface is elongation. So what the stress at the top? Compressive. What the stress at the bottom? Positive. And what the stress at the neutral surface? Zero. So surface to surface, what happens now? Surface to surface change in length is changes. Surface to surface change in length is changes. When the change in length changes, strain will change. When the strain changes, stress will change. That's why what now? Stress is proportional to y. That y is what now? Distance of a fiber from the neutral axis. Distance of a fiber from the neutral axis. This is what now? Top fiber. This is the inner fiber. Inner fiber. How many fibers are there now? Infinite. So this distance is called as what now? Y. What the y now? Y the distance of a fiber from neutral axis. Y the distance of the fiber from the neutral axis. At neutral axis y is 0, so bending stress 0. Where the y is maximum at top and bottom. That's why bending stress maximum at the top fiber and bottom fiber. So all the terms I explained now. Only the neutral axis has to be explained now. Only neutral axis has to be explained. Already said the bendiment you have studied. R you have studied. What the R now? Radius of, everybody is going to tell radius of curvature. That's all. Radius of curvature of neutral surface. And what the Y? Distance of a fiber from the neutral axis. Fiber to fiber, what happens now? Y will change. So where the Y will be maximum? At the top and bottom. So bending stress maximum at the top and bottom. Why now? Just now you studied now. I'm getting a more compressive, more contraction. More contraction means what? A more compressive strain. When the strain is compressive, stress also going to be compressive. Stress is maximum. I'm getting a more decrease in length. More decrease in length means what now? More compressive strain. Then more compressive stress. Here I'm getting what now? More increase in length, more elongation means more tensile strain. Then stress is going to be a maximum here, no, tensile stress maximum. Here change in length is 0. Change in length is 0. When change in length is 0, strain is 0. Then stress is 0. At the neutral surface or the neutral axis, stress is going to be 0. So what the neutral surface now? Neutral surface, a surface whose length will remain same even after bending. And capital R is the radius of curvature of neutral surface. But when I'm going to pull it, what happens now? All are elongated. When I'm going to pull it, what? All the surface are equally elongated. Means everywhere the what? A change in length is same. Everywhere the change in length is same. Means everywhere the strain is same. Everywhere the stress is same. That's why what now? What you have studied? Axial stress uniformly distributed. When I'm going to pull a bar like this now, all are equally elongated. Means all the surface are equally elongated. Means what now? At every surface, what now? Strain is same. When the strain is same, stress is going to be same. That's why you are going to be axial stress are uniformly distributed. But when you apply a bending couple, what happens now? One side I am getting more contraction, one side I am getting more elongation. More contraction means more compressive strain, means more compressive stress. And I am getting more elongation. More elongation means more tensile strain. More tensile strain means more tensile stress is going to be there now. But if I am going to change the directions here, now this is a clockwise. This is anti-clockwise. What happens now? This bottom surface gets contraction. These couples are going toward the top. Top surface gets contracted. So if I change the direction, this is a clockwise, this is anti-clockwise. Then bottom surface contraction. Then top surface elongation. Then what the shape you are getting the top now? Convex you are getting now. This bottom surface gets contraction. Top surface elongation. Then what the shape you are getting at the top now? Convex you are getting now. So this is what once again when I am going for the bending chapter, bending stress chapter, this are not going to be explained now. Where directly are going for the problems only. Somebody will ask, sir, why you are in the first chapter you also need the questions on eccentric axial load is there. Eccentric axial load equal to axial load and bending. Then you need the bending stress calculations required. That's why I'm explaining all now. Similarities are going to be there now. Swaraj Pandey, after a long time, for morning last 4 hours, you are not active in the live chat. After 10:53, almost after 1.5 hours, there is a Mr. Swaraj Pandey came onto the live on the live chat now. Per last 1 hour 20 minutes, nobody is what now active on the live chat. So this I'm going to discuss. I'm going to give. Let me complete this one now. This I'm going to discuss afterwards. The same concept is going to be there now. Anybody, what is meant by bending? What is the bending? What is the bending and twisting? Here, why this length is decreased? Why length is increased? This cross section is rotated. About which axis now? This couple is about which axis now? X-axis. X means HCA. So this is HCA. So this cross section rotated about which axis now? HCA. This cross section also rotated about HCA. Since the cross sections are rotated about HCA, they are rotated like this because the couple is a clockwise. It is anti-clockwise. So what is the meaning of bending? Rotation of a curve. Because of the bending, what happens now? One side length is decreased, one side length is increased. But why you are getting what now? Length is decreased or increased now? Cross sections are rotated about HCA. So rotation of a cross section about HCA and VCA is nothing but a bending. Rotation of a cross section about HCA or VCA is a bending. Why no? Bending couples are always about which axis? No? HCA and VCA. But this couple is about HCA or VCA? HCA. Similarly, the couples are in horizontal plane. Couples are horizontal plane means about which axis? No? VCA. Like this now. So the cross section will rotate what like this now. Now this is the rotation about this axis what now? This is which axis now? VCA. This is HCA. So this is a rotation about which axis now? VCA. This is rotation of cross section about HCA. This is rotation of cross section about which axis now? Polar axis. Cross section made this is about HCA or VCA? HCA. So this is a rotation about HCA. This is a rotation about VCA. This is a rotation about polar axis. Polar axis. So what's the difference between bending and twisting? When a cross section rotates about HCA or VCA is a bending. Twisting means what now? Rotation of a cross section about polar axis. In this case, what? This couple is about which axis? Polar axis. Then the cross section will rotate about polar axis. If you ask the most of students now, what the bending couple and twisting couple means? Sir, when a member is in bending, it is a bending couple. When a member is in twisting, it is incorrect now. Bending and twisting are the effect. Bending couple means what? A couple perpendicular to cross section. Twisting couple means parallel to cross section. But what is the bending? Bending means what now? Rotation of a cross section about its HCA or VCA. This about HCA. This which is case HCA. This VCA. But how do you know it, sir? Is it about HCA or VCA? Identify the couple. This couple is about which axis? No, HCA. So this cross section rotate about HCA. Suppose this is about which plane? A horizontal plane. Horizontal plane means about which axis? No, VCA. This is going on which side? No, back side. Back side. So the back side fibers are come nearer now. Front fibers goes far away. Back side fibers come nearer now. Front fibers are goes far away. So here like this now. So back side length is decrease. Front length is increase. So why this is what now? Why back side length is decrease? Why front side length is increase now? Because the cross section rotated about VCA. So rotation of a cross section about HCA or VCA is a bending. But how do you know it means what now? Identify the couple. If the bending couple about HCA means cross section will rotate about HCA. If the bending couple about VCA means cross section will rotate about VCA. Then what the twisting? Twisting couple always about which axis? A polar axis. So the rotation of a cross section, this is what a polar axis. Is the rotation of a cross section about polar axis, the twisting. So if somebody will ask what the twisting and bending mean, what now? Rotation of a cross section about polar axis, the twisting. Rotation of a cross section about HCA or VCA is a bending. But how do you know it about HCA or VCA? Identify the bending couple. In this couple, what? The couple is about HCA. So cross section will rotate about HCA. This is in which plane? A horizontal plane is about VCA. So cross section will rotate. This is what now? This is what now? Cross section rotate about VCA. It is also bending. Only last one, let me complete it. Neutral axis also. Neutral axis. What is the neutral axis now? What are all these blue color dots? What is all these blue color dots? Blue color dots are the neutral axis. Blue color dots are the neutral axis. Neutral axis. How many neutral axes are going to be there? Infinite. What this dot now? Neutral axis of a cross section on the left side. Is the neutral axis of a cross section on the right side. So what is the neutral axis definition? What is the neutral axis definition? What this line now? Cross section. What this blue color line? Neutral surface. The blue color line is the neutral surface and red color line is the cross section. And what about this dot now? Dot means perpendicular to this board now. So this is HCA. So what is the neutral axis now? Neutral axis is the line of intersection. Neutral axis is the line of intersection of neutral surface with a cross section. Neutral axis is the, this is what now? Neutral surface, and this is a cross section. And what about this dot now? Line of intersection of neutral surface with a cross section. Assume my hand is a cross section. My hand is a cross section. And my right hand is about a cross section. My left hand is a neutral surface. This is what now? My right hand is about now? Cross section. My left hand is a neutral surface. So wherever these two are intersecting, this line of intersection is what now? Neutral axis. What this red color line now? What this hand now? Cross section. This is neutral surface. So what this my left hand is doing now? Intersecting this now. So what this red color line? It is the intersection of my left hand with my right hand. Right hand is the cross section, left hand is the neutral surface. Wherever these two are intersecting, this line is called the neutral axis. So what is the neutral axis now? Neutral axis is the line of intersection. Line of intersection of neutral surface with a cross section. Like this is a neutral surface. Like this, how many cross sections are there? Infinite. Is a neutral axis of left side cross section. Neutral axis of intermediate. Is a neutral axis of right side cross section. I'm going to keep the mobile phone like this now. My two hands are the what? Cross sections. My two hands are the cross sections. Mobile phone is a neutral surface. Mobile phone is a neutral surface. If I keep it here, what is the top surface? Here the neutral surface whose length is remain same. So this mobile phone is what now? Intersecting. Mobile phone is a neutral surface. My two hands are the cross sections. This is what now? What this line now? Intersection of mobile phone with my hand. My hand is the cross. Mobile phone is the what now? Neutral surface. So this line is the intersection of mobile phone with my hand. My hand is the cross section. Mobile phone is the what now? Your neutral surface. Similarly, what now? What about this now? Here one more. What once again? What this red color line? Intersection of this mobile phone with this cross section. So here how many cross sections are taken? Two cross sections are taken. I'm getting the two line of intersection. What these two red color lines now? These two red color lines are the what now? These are the lines where mobile phone is intersecting. My mobile phone is the what? A neutral surface. My two hands are the cross sections. Since I have taken the two cross section, two line of intersection, but in between how many cross sections are there? Infinite. So these lines are called as the neutral axis. My hands are the cross section and mobile phone is the neutral surface. Since I have taken the two cross section, two neutral axis. Like this, how many cross sections are there? Infinite are there? No? Infinite neutral axis. Neutral surface is one. Neutral surface is one. Neutral surface for a member. Neutral axis for a cross section. How many neutral axes are going to be there? Equal to number of cross sections. So about 10 cross section means 10 neutral axes are going to be there. But where you can see this now? Where you can see my hand. My hand seeing from the front, this is a cross section. Where you can see what? Seeing from the front, this will become as a vertical line. This will become as a vertical line. And what about this red color line? This can be what now? Seeing from the front. My hand is a cross section. This will become as a vertical line. And what about this line of intersection will become as a dot? That's why you are shown with a dot now. This is a cross section. Cross section. And where you can see this what now? This red color line. The line of intersection can be what? Seen from the side view. Seeing from the front is a dot. So both can be seen where now? Where you can see both this now? Shape of my hand. Always this neutral axis can be seen in the shape of the cross section. Where you can see my shape of my hand now? Side view. So neutral axis always can be seen in the plane of cross section. Now this is the cross section. So this you can see the neutral axis now. So neutral axis always can be seen in the plane of cross section. But in the front view, what happens now? Cross section will become a vertical line, neutral axis dot. So neutral axis always can be seen in the plane of cross section. So here, this member is horizontal. Cross section can be seen in the side view. So neutral axis can be seen in the side view. This is a neutral axis. Once I am mentioning now, number of neutral surface is only one. Neutral surface for total beam. Total beam is a neutral surface. Neutral axis for a cross section. Number of neutral axes are equal to number of cross section. Number of neutral axes are equal to number of cross sections. Overall, the neutral surface, neutral axis is what? A neutral surface is a surface whose length remains same even after bending. But neutral axis is what now? Line of intersection of neutral surface with a cross section. So neutral axis always can be seen in the plane of cross section. And that neutral axis coincides with HCA or VCA. In case this is a vertical bending, where you can see the shape of this now? In vertical plane. In vertical bending, we can see the neutral axis. In vertical bending, neutral axis can be seen in the side view. So in vertical bending, neutral axis coincides with HCA. Vertical bending. Vertical bend means couples are in vertical plane. This curved shape you can see in the front view. So in vertical bending, neutral axis coincides with HCA. Horizontal bending, neutral axis can be seen in the neutral axis can be seen in the what the top you can see it now. That is what now? In horizontal bending, neutral axis coincides with VCA. In vertical bending, neutral axis coincides with HCA. Horizontal bending, neutral axis coincides with VCA. All the textbook they are showing this only because they are dealing with a vertical bending. But machine components are subjected to horizontal bending. Then in that case, neutral axis coincides with YY. YY will become the neutral axis in case of horizontal bending. So this about this now. Now this is about the pure torsion. Here torsion equation, this I am going to explain it after the break now. Because they are all interrelated, I continued it almost now. So we'll take a 20 minutes break. After a break, I am going to discuss the pure torsion. Now we can take a break for 20 minutes. After a break, I'm going to explain the pure torsion. So with this one about all the basics. Pure axial loading, pure bending, pure torsion. Then we are going for the questions. We are going to discuss it now. And this definition also I'm going to dictate it after a break now, after 20 minutes break now. So thank you one and all. We'll meet after 20 minutes now. If any doubts, quickly vote now. Any doubts? Try to send your queries quickly now. Otherwise, take a break. After break also you can ask your doubt now.